we begin with our keynote lecture session. The session will be chaired by Professor Sanjeev Pereira. Let me introduce him with a short bio. Professor Sanjeev Pereira is a chair professor of mathematics and director of the Center for Mathematical Modeling at University of Colombo, Sri Lanka. In 2025, he was honored with the National Educator Award, Gold for Excellence in Teaching Scholarly Work and National Contribution in the Discipline of Mathematics and Statistics. He holds many international affiliations and his current work focuses on health impact research, utilizing artificial intelligence and machine learning to model the transmission dynamics of infectious diseases. Now it is my privilege to invite our first keynote speaker, Professor AKB Chand. Professor Chand is a professor in the Department of Mathematics at IIT Madras. His research spans fractal approximation theory, interpolation, radial basis functions, fixed point theory, and computer-aided geometric design. He has supervised 11 PhD scholars and published over 120 research papers in leading international journals, making significant contributions to computational mathematics and scientific computing. May I now request Professor Chand to kindly deliver his keynote address on the title Computational Modeling Using Fractal Radial Basis Functions.
Yeah. Audio proof. Yeah. Okay. Okay. So I am thankful to the organizer for inviting me for this ICCMES 2026 at ITR SOA University. So since I am from Odisha, so it is always I am delighted to come here and talk anything on mathematics to the new generations. So today I will talk on computational modeling on fractal radial basis function, approximation theory and learning problem. So this topic has different directions. So firstly, if you see the title, okay, so this is fractal, it is one direction. When I started my research work around 1997, so it was in nascent stage, and so the work whatever I did in my PhD, that was different from the domain of my guides. So I had to do everything on my own as a PhD scholar at IIT Madras, IIT Kanpur. So I developed lot of theory on fractals. So there are numerical aspects. So I use numerical analysis and approximation theory in the fractals, and then we work on different directions, say preserving fractal functions, and then also we work on computer geometric design to construct the fractal function using fixed point theory to solve the different differential equation using fractal functions. And recently we have seen lot of applications are going on machine learning. So because fractals they use directly in some machine learning problem, but I found it is difficult unless you develop some kernel. Okay, so that's why in order to develop the fractal kernels, so we work on this fractal radial basis functions. So I will come to that point. Okay, so today on my talk I will talk on fractals and IFS theory, because if I will tell directly fractal functions, it will be difficult for you to catch what is fractal function. It is not like polynomial or sine, cosine, it is something different. Okay, so most of you are not familiar with fractal functions. Then why I choose a radial basis function, I will explain that part. Then in particularly this is fractal multi-quadric function, so that we have been developed recently, and then by fractal multi-quadric function one can approximate a different type of complex functions, or you can use them for the solution of the differential equation. Then there is some limitations when you apply fractal radial basis function. So sometimes you will get a system of equations and the system may be ill conditioned. So that's why we thought of developing something called quasi interpolation. There you don't have to solve the system of equations, then we construct the whatever multi-quadric function. This is in R2 we have done, but the same thing one can go for the higher dimension. So, once you develop the fractal ideal basis function, so this part is basically a kernel which can be used in the machine learning part, and the last part we have used for the classification problem. So, fractal, so this it was developed by Mandelbrot from 1975. So, this came from the word fractus. Fractus means if you see an object is very irregular, so you break the object and then you see the small part, again you break it. The same thing if you see the broccoli or cauliflower, the whole thing it is very complex. You take a part of this broccoli, again you break it, again you see it. Okay, so in that way you can find the small part of a broccoli is equal to the big part of the broccoli. So, therefore, there is a self similarity, same thing is there. So, if you see the tree, a big tree is very similar to the branch of the tree. Okay. As a mathematician, what we need actually? We need some mathematical transformation from the whole tree to the branch of the tree. If that is there, we generate the tree. Okay. So, you capture anything in the nature. Suppose you want to construct a cloud. Okay. You take a bigger cloud, then you take a small cloud, find the maps, okay, then give some rendering, use some computer graphics, you will get the mountain. So, this cloud or mountain, you take any irregular object. Okay. So, when you come to regular object like this table, okay, leaves, so which things are smooth? So, that is there in the classical geometry. Okay. The things which are irregular, which is not described by the Euclidean geometry, then we go to the fractal geometry. Okay. So, you take any complex natural objects, so they are very much irregular. Okay. So, you take your heartbeat or stock market signals, everything you take. Okay. So, these are irregular things. Okay. You cannot use the traditional things to capture them. So, therefore, we need a new tool. So, that is why this fractal came, and here fractal has no universal definition. Okay, like we define, very difficult to define what is life. We have to give some characteristics to define a life. So, similar way, so it is difficult to define a fractal. So, therefore, there are some properties are there. F has details on arbitrary small scales. Okay, if you take small scales means if you zoom anything, so therefore, you can see the details again. Okay, I will give some pictures. F is too irregular to be described through Euclidean geometry. Sometimes it has self similarity, it may be approximate or statistical. Okay, and there is something called fractal dimension of F is greater than topological dimension. Okay, so dimension we will not find, line has a dimension 1, okay, point has dimension 0. So, these are the topological dimension, but in fractal case if the things are very irregular, so fractal dimension is not like 1, 0, it may be some fractional values, and in most of the cases F defined recursively through initiator and generator. You start with a simple process, you take anything, I will explain that part, initiator and generator, you take anything and then you apply some rule there, that is called generator, then you will get the fractal. So, first the popular way to construct the fractal is iterated function system. There are different way one can construct the fractals, like Brownian motion is there, okay, or you can use the iterations of complex function, you can get the fractals. Okay, so, there are various ways to construct the fractals, but there is another way which is called iterated function system. You take any space and take finite number of continuous map. So, if you take them together, we will get something called iterated function system. If each map is a contraction, okay, so because if contraction obviously it is continuous, so therefore, that is called hyperbolic IFS. So, therefore, here you take h of x as a set of all non-empty compact subset of x. If x is there, so you take actually all non-empty compact subsets of x. So, then you define a matrix there, that is Hausdorff matrix, because in the nature if you see anything, okay, whether if you take a flower here, okay, so if you take the boundary or you leave the boundary, okay, so it is the, for our eye you cannot distinguish that one. So, therefore, you assume everything to be like closed. Okay, so, if this is closed, then this is the closed. So, I can compute a distance between these two flowers. Okay, so, that is why we assume everything to be compact there, and there you can define this h of BC, this is your maximum. So, of these two distance, because it is not symmetric, if you define only this one, it is not a symmetric. So, therefore, you take maximum, you will get the symmetricity. So, H is a metric here. So, if X is complete metric space, one can prove that this H of X, that is also complete with respect to this metric, induced metric H. So, this H is called this H and capital H with the metric H, it is called Hausdorff space. And here you can take, if you take any set and you can apply map here W of B equal to, you have n number of maps are there. These are the small map, as I said. If you take a broccoli, then you any small part of the broccoli, then you have to find the map, so that, so these are those maps actually. Okay, you are breaking the object to small parts and then you are finding the maps from the whole part to the small parts of the object. So, if I is hyperbolic, means each of them is contraction, then this capital W is also contraction. Now, capital W is a contraction, this is a complete metric space. So, therefore, what will happen? There is a fixed point. Okay, so, we are using here fixed point theory, there exists a unique set for which W of A equal to A. So, this is called deterministic fractals or iterated function system. Okay. So, here if each Wn can be given some probability, then you can define the Markov chain and then you can go for the measure. Okay. So, that is a different aspects. So, one can construct the recurrent fractals by using the probabilistic approach. Okay. So, we will not do that one. So, this is a deterministic approach. So, we are familiar with Cantor set. What you do here, you take 0 1 interval and you take a map 1 by 3x. So, this will give me the 1/3 of this. This is the one part of this, 1/3 of this original set, and similarly you just translate it by 2 by 3, you will get another part. So, therefore, you do it recursively. So, therefore, each stage you are finding 2 more sets here. So, therefore, 2 into 2 here will 4, then 8, then 16 like that. So, it will continue. So, therefore, you will get something called Cantor set. So, if you find what is the length of the Cantor set, that is 0. Okay. So, how many points are there? It is infinite. So, therefore, it is not a 0 dimensional object or 1 dimensional object, because in one case it is infinite, other case it is 0. Okay. So, therefore, it is infinite to 0. So, therefore, what we say actually, so at some points, okay, it is varying between infinite to 0 means, so you will find a particular value for which this has a finite measure. So, that will give you the fractal dimension. So, the dimension of this set is log 2 by log 3. Okay. So, there is some formula how to get the, because we have 2 parts and the contraction factor is 1 by 3. So, therefore, ln 2 by ln 3. The same thing, there is a triangle. So, what you do here, you can remove the middle part of the triangle. So, whole triangle is contracted by 1 by 2 in the x direction. So, first we are getting this triangle. So, therefore, half 0 0 half x1 x2, that means I am contracting the triangle to this, then I am shifting by half here, then I take the middle part, then I shift the other part. So, therefore, I am getting W1 W2 W3. So, the same triangle, now we can repeat the process. So, we will find what is called Serinspeak triangle. So, this was developed in 1904 or 5 in the topology. Okay. So, these are called the pathological objects. So, here area equal to 0, okay, but the length is infinite. So, it is not a 1 dimensional object or 2 dimensional object. The dimension is between 1 and 2, that is log 3 by log 2, because 3 maps are there. So, scaling factor here, the contraction factor is half, or you can get the spectral radius of all these matrices, that is half. So, therefore, you will find the dimension is log 3 by log 2, which lies between 1 and 2. So, these are different objects which are generated by fractals. So, this is a coral, this is a tree, this is a leaf, this is a feather. So, if a very complex pictures are there, so we can get them by using fractals. So, therefore, in the nature, if you want to capture anything, okay, so it is better to use the fractals. So, fractal interpolation function. So, if you have a data points, okay, so our aim is to construct a fractal function which is passing through those points. Okay, in particularly, if you take the stock market data, okay, you see it is very irregular. So, what we will do here, you take some points x0 to xn, n plus 1 number of points are there. Okay. So, in the x direction, all these bigger interval can come to the small interval, because our aim is to get the contraction map. Once you get the contraction map, so then we can construct the IFS, because from IFS I can get the fractal. So, this fractal interpolation function, it is constructed through iterated function system, which I explained earlier. So, I need the contraction in the x direction, then I need the contraction in the y direction in this way. So, this is a contraction map in both x and y. If I combine them together, so I can get a contraction map. The second map has two contraction in the second variable. So, therefore, you can take the value of SI to be less than 1. So, once you get the value of SI is less than 1, so for the affine case, so if you take, so this MIX to be a simple map CIX plus EI, so we will have the two conditions Wi of x0 y0. So, this endpoint is coming to the bigger interval or bigger domain is coming to the subdomain. So, that is the condition we have imposed. So, here you have 4 equations and here this SI is a free variable, you can take different values of SIs. So, therefore, you can get the AI, CI, BI, EI, all these parameters you can compute and then you can get the each elementary map Wi. So, once Wi is ready, so you can get the capital W and then, so there is a little bit theory is involved here. Okay, so you need little bit function analysis. Okay, you take a function space and there. So, the IFS this construction is basically I am using iterated function system and then little bit from the functional analysis to get the functional equation for this fractal function. So, this is the theory. You take a function space and you impose two conditions, then you will find there is operator. This operator is contraction because the SI is less than 1. So, therefore, you will get a fixed point. So, here the fixed point is f star UIX plus SI f star x MIX. So, this is the condition MI in the classical case. So, we have a explicit formula, but in fractal case, so you can see f star is defined through f star. If some values are given, then I can get the new values. Okay, so, therefore, if you have n plus 1 values in the first iteration, in each sub interval I can create again n number of values. So, I will do it for the n number of intervals. So, therefore, you will get n square times n plus 1 values. Again you do the same thing. This is a iterations. Okay, so, this is the like generator and initiator is just your n plus 1 points. You repeatedly apply it and then you can see this is the fractal function. I will show the example. Suppose you have 4 points are there. So, here between these 2 points, so I should have another 2 points, here I should have another 2 points, here also I should have another 2 points. So, therefore, this is like that. If you do it, so you will get very irregular function. So, this is the fractal function which is very irregular in the nature. So, therefore, I can vary this value SI. So, if I vary this value SI, then I can get the different structure. For the same interpolation points, I can get infinite number of functions. Okay, so, when you are applying in different type of problems in various natural phenomena, okay, so then you can fit your data through fractal functions. Okay, if you take your ECG or EEG signals, okay, in the healthcare, so you have very complex data is there. Okay, so there one can fix those type of data by using fractal functions. If you take the classical way, sine, cosine, exponential, that will not work there. Okay, so therefore one has to optimize these parameters. So, differentiable fractal function, even if you see this is maybe not nowhere differentiable because it is varying very irregularly. Okay. So, when I was doing PhD at that time, Bransley and Harrington, they constructed some splines. Okay. So, but the spline means here the function may be smooth, but the derivative may be irregular. So, he constructed the splines, but it was not good, he was not getting all type of boundary conditions. Then we developed that one. Just here I constructed the cubic spline at that time through moments. So, I will skip this part. So, here just to get the feeling what is the fractal splines. So, I am showing that one. So, here it is passing through 4 points. So, 1, 2, 3, 4 points are there. So, here if you take the second derivative of this function, it is very regular. Okay. So, if you want any phenomena where the function should be smooth, but the second derivative is irregular, then you can approach through fractals. So, same thing will happen here. For the same data, here what I do, I changes this parameter S, because S is the free parameter. If you change the value of S, again you can see some changes are there in this here the middle last part of this graph. So, therefore, if you take the double derivative, you can see this is also very different. So, obviously, if you integrate it, so these are the integration of these graphs, or this is the derivative in this way. So, if you take the derivative of this function, it will landed here. If you take the integration of that, landed here. So, similarly, so you can another cubic spline. So, this is passing through the same 4 points, but here I am changing this value. the last 2 point it is 0. So, therefore, you will get the, here you can see it is very similar to the classical spline where all values are 0. So, here you can see this is a irregular function. In the classical spline you will get only this type. Okay. So, therefore, fractal function it is more general than the classical functions. If you vary the value of s, you will get the infinite number of functions. So, radial basis function. So, this radial basis function it was studied by Hadi. So, he is not mathematician, he is a geologist. Okay. So, he was working on approximation of different complex structures in topography. Suppose you want to approximate a mountain or any other thing. So, in that case, so he found it is difficult to apply interpolation process because you have to do sampling and then you have to do the interpolation in the higher dimension. What he did actually, he took a single function and then he translated it. He took one function, then translate it, then he formed the basis by translation of a single function. Okay, so that will give you what is called radial basis function. So there are several radial basis function like multi-quadric function, there is inverse multi-quadric, there is Gaussian. Okay, you will find several number of radial basis functions are there. In 1982, Franke he popularized this multi-quadric method out of these 32 common radial basis function, and it was first used by Kansa to solve the partial differential equation. So, this radial basis function it is used for interpolation and approximation. Okay, so, it is very popular for the scattered data interpolation. Okay, so, if you have a data which is scattered in nature, so therefore, one can use a radial basis function to interpolate that data. So, it has plenty of applications radial basis function like sea temperature modeling, delay differential equation, rainfall prediction, numerical mixing problem, machine learning and deep learning. So, we use radial basis function as a kernel. Okay. So, the question is whether you can use something fractal, you can use, this is a two different method. Okay. One is fractals, another is radial basis function, there is no connection. Okay. I was trying because I developed several type of fractal functions. Okay. So, I thought how to get the fractal function. Okay, if data is given in the scattered manner. So, there is no theory on the to approximate the scattered data in fractal interpolation. So, that is why I gave to my students long back, but it did not work. Then I was thinking how to do it. So, recently 5-6 years back some student came, then I gave this problem. Okay, so, I tried to construct that one. So, this theory is entirely new. Okay, so, our aim is fractal has the same properties, you can interpolate, you can approximate, radial basis function has the similar nature. Now, the thing is how to bring these two different subjects to a common platform. So, that is why I thought of using this fractal radial basis function. So, so that is the motivation behind this work, and to apply these kernels for different type of machine learning problem. So, one can use the same thing for the different type of healthcare problem. You take any data from the healthcare, you can use classification or you can do the prediction. Everything can be done by using the radial basis, fractal radial basis function, which will give the better result over the existing radial basis function. So, if you have a data theta in Rs, okay, we seek a function f of Rs to R, so that it will approximate it. Okay, so, in practice f is not known. Okay, so, we can assume the existence of such function. Okay, so, what we do here, we can in the radial basis function you take a function and you define a map. Okay, so, I will put the condition here. Okay, suppose this theta is given x1 to xn, n number of points are there. So, my aim is to approximate the original function by this capital S of x equal to summation j equal to 1 to n lambda j phi of norm of x minus xj. So, I am taking a single function and I have n number of points are there. I am taking translation of this will form the basis here, and I have to get the values of lambda j. Okay. So, here this condition is there, since x1 to xn is there. So, I can put here x1, x2 like that, I will get n number of equations here. Okay. Then I need the values of lambda j. So, therefore, you will get a matrix here. Okay. So, impose this condition in order to find the values of lambda j. Okay, I will get a matrix here. So, that is phi of xi minus norm of xi minus xj. Okay, now, the question is whether inverse of A will exist or not. If the A is invertible, then you will find the lambda j, then you can get the approximation of fx by sx. Okay, that is whether one dimension or higher dimension. This method is simple, so it is known as meshless method. They use this one in the finite element method. Okay, so lot of PD has been solved by finite element method, that through meshless method. So therefore, our aim is to get this lambda through from this equation where this A is required. So therefore, sometimes difficult to compute, the matrix may not be invertible. So that's why you use quasi interpolation there. So Aij here, this is your norm of phi of xi minus xj. So here we have to solve this one to get this values of lambda. So therefore, what they do in the machine learning, so if you have any data is there, approximation is required. So you train the model, find the value of lambda, then you test it, you divide the data into 80 and 20, then you predict the value of lambda, then use the same thing for the testing. Okay. So now this is fractal multi-quadric function. Okay, so here what we do, this original function is, this is a multi-quadric function. So I want a fractal characteristics of this multi-quadric function. What you do here, the function is given, I can take a partition here, I can construct the map ui in the x direction. For y direction I can define some map here, but one has to choose what is the maximum distance grid here. Okay, so here you need the value of k, because this function has to be symmetric, it is called radial basis function. When you come to R2, your center is 0, this has to, the graph has to be symmetric around 0. So therefore, I will take a partition in the right side of 0, then I duplicate the same thing to the left of the 0, and then I will choose some scaling function here. Instead of si, I have written alpha I. So you do the same thing, then you define some operator there in a complete metric space. You define an operator there, and one can prove that this operator is contractive in nature. So therefore, we can get a fixed point here. This fixed point is written as phi alpha uir plus phi of uir alpha times. So this is a base function. So if you change the base function or alpha I, you will get different type of radial basis function, that is called fractal radial basis function. So we did this work, it is published 2 years back in the SAM Journal of Numerical Analysis. So here you take n equal to 3, suppose you are taking this 0, 1 by 6, 1. So therefore you can see the difference between 0 and 1 by 6 is 1 by 6, it is a grid point, 1 and 1 by 6 is 5 by 6. So therefore we take this one, because this type of partition is required when we are solving some differential equation. So you replicate this one on the left hand side, then you take a base function which will satisfy the end condition, phi of the end, this phi value is given, the multi-quadric function must match at the end points. So I can choose a base function, and then I can get the fractal function here, and if you change the values of this c or alpha, so you will get the different type of radial basis function. In classical machine learning problem, so they only optimize these values of c, and in fractal case now you have two more parameter, one is your alpha I and another parameter is this b base function. You can change different base function and you can get the different. So this is the fractal multi-quadric function. So around 0 you can see these pictures are there. So these are the radial basis function. It is symmetric here around 0. Okay, so these are the fractal functions which are symmetric in the nature. So you can see different type of, for the same multi-quadric function. Okay, we got the different type of fractal multi-quadric function. So these are given in all these pictures. You can vary the parameter, c equal to 2, here c equal to 20, but the alpha value is same, and here we change the different values of alpha, and here is the different values of alpha, there we change the base function. So therefore different parameters are there with the fractal radial basis function, and you can change it. One can construct the smooth one, means you can construct the radial basis function whose derivative is irregular. Okay, so I will skip the proof, and similarly one can solve the initial value problem by using the radial basis function. Suppose you have some differential equation is there subject to some initial condition. Here we have used the collocation points. So these are the partition, and then you use the collocation points here, and then you try to get the values of this radial basis function. This is the approximation of the function, and we need all these lambda j, and here j to l plus 1, here l plus n plus 2 values are required to compute this lambda j. So impose this condition, then we have the collocation points are there that will help to get the values of all these lambda j. So, here we try to solve a differential equation. It is simple one, but y dash plus y equal to eta x. So, here what is the eta x? Eta x is a very complex function. So, it is not the simple one. So, here so I will show the what is then the right hand side, y dash plus y equal to something very irregular function. Okay, so, it is not a smooth function, it is very irregular function. So, what we expect here? We expect a function whose first derivative is irregular. So, that is possible only through fractals. In classical case, it is very difficult to get such functions. So, we have this analytical solution is e to the power minus x plus f beta x, this is a fractal function. So, here we get how to get that function, we take a sine function and then you do the perturbation. So, here you try to get the solution of this one by using the radial basis function. So, you take the partition of this interval, then you choose the collocation point there, then you try to get the values of lambda 1 to lambda 6 by using our procedure. So, here you construct the fractal multi-quadric function, then you impose all those conditions and I will get the approximation, then we have some few observations the value of b. So, here this is the graph of eta x. So, here you will find the different solution. This analytical solution is given with the blue color and here you can find, if you take different values of alpha, then you will get the different classical radial basis, fractal radial basis solutions are there. So, here this is the analytical solution, and when alpha equal to 0 in the classical method, here you are getting the error is too much, but in fractal case you can see this is close to the given solution. We have not used any optimization method here. So, that is why you are finding the graph is a little bit gap is there. If you choose your alpha very approximately, then you can get the solution. So, similarly one can get the approximation. So, if any function is given, one can get the approximation this one. We use the classical method by Bitson and Powell and we try to approximate this one. So, this is the radial basis function, one can get the values to be order of h depending on the partition. So, here also we have given the example, suppose f star is a very irregular function, then one can use the radial basis function. So, this is a irregular function. Okay. So, for such type of function, if you take the classical method, you will not get the approximation to these functions. Here what we use is the fractal radial basis function and we try to get the approximation of these values. So, you can see some values are very close in the fractal method. We have not optimized these values. So, that is why these are little bit different from the original one. So, in classical case you will get this approximation, okay. So, whatever classical function you will take, so this will be far deviating from the original function, but in fractal case it is possible to go too close to the original function. The same thing, whatever I am showing this approximation problem, the same thing can be taken in the healthcare problem. You take any problem which are very data is very regular, you want to get the approximation to that one. Okay. So, then similarly fractal quasi interpolation, it is a similar setting, you do not have to compute the values of A inverse there and directly if function is given, if these values are, you are able to construct this f0 derivative at this point, first point at the f0 f at x0 and all these values are given here, fn is the last end point values, the derivative values. So, you need this basis function, if you construct this basis function, these are the fractal radial basis functions. So, I constructed different basis function here, psi j alpha, beta n alpha, gamma n alpha, beta 0 alpha, gamma 0 alpha, all these are given here, then you can get the approximation, the original function f by LC alpha f. So, this is a problem. Suppose you want to construct a function whose derivative is very similar to like that. So, here we use the fractal technique to approximate these. So, here you can see that is the original function, this is the fractal method, alpha 1, alpha 2, here 2 method. In classical case there is a little bit more errors are more. Okay. So, in the classical case this error is more, here you can see this curve. Okay. In fractal case this error is less. So, similarly you can construct the fractal function which is twice differentiable and that can be approximated by using also in fractal function. There are some convergence theorem and reproduction property, other things are there. So, I will skip this part, just I will move to the all these are approximation part. So, then there is another operator, if you do not want derivative values, then this is another operator LD alpha. So, we are now using this one to solve some Black-Scholes equation and other things in partial differential equation. So, I will skip this approximation part of approximation by LD function. So, this is also same thing, it is a very complex function, we try to approximate this one by different fractal radial basis functions. So, then this is the last part. So, if you take any data in the Rn, because in machine learning problem the data may arise in the higher dimension. So, therefore, what suppose theta x1 to xn, these are the data points in array. So, I need a function which will approximate these data points. So, this is basically a scatter data interpolation. So, here you take k equal to maximum of this norm of x minus xj. So, here you will find the largest diameter over that all these points, and then you will find the value of k. So, in the k you take the partition here, because we do not have to go to the negative direction, because in the higher direction you will get a circle or sphere or something like that. Only I need the radius. In the radial direction, what I did a partition here. So, this is your ui, and similarly you construct the vi, and then you combine them, you will get the fractal function by using some base function, as I said in the earlier theory. Similarly, you define a operator there and you will get a fixed point. Okay, so, this is the nature of this fractal function. So, in the higher dimension what we will do? So, we did this one for r values lies between 0, this is a real number. So, therefore, if you are in the higher dimension, you take the same function and find its norm, then you will get the what is called fractal radial basis function. So, this is we published 2 years back. So, here I have taken this example 0 1 0 1. So, data points maximum radius will be root 2 here. So, k equal to root 2. So, you take the phi x, this is your inverse multi-quadric function, then you take the partition 3 partitions, then you take Hermite function and we get the fractal function. So, I will show that one. So, these are the different type of radial basis function. Okay, so, you can see these radial basis function, they are not smooth, okay, but they are irregular. So, when you want to classify, okay, in the machine learning problem, okay, if you need a hyperplane where one type of data is here, another type of data here, okay, you need a hyperplane there. So, you can use this type of very complex function to separate the data by using it. Is not a smooth one. Okay, in the classical case, when they need the classification problem, they need a hyperplane. So, that may be very smooth, but in fractal case you have various type of structure, because this alpha value you can change as per your wish. So, therefore, I have changed actually this value, and I have shown actually how these different type of hyperplanes are possible by using the fractal techniques. So, this is also a smooth fractal. So, you can construct a smooth function whose derivative, but except in the center, because center you are moving from a 0 to a non-zero value, there may be non-differentiability will be there, then there is some condition. So, when the phi of this is going to be strictly positive definite, the radial basis. So, here we need some classical result. Okay, so, because I have to compute that value of in the approximation problem. So, little bit here we use the harmonic analysis and Hilbert space concept to get the this matrix must be constructed so that it is invertible. So, that theory we have given here. So, I will skip this part. So, here you try to approximate a function which is very irregular. Okay, so, this is a function which is irregular. So, you take the simple radial basis function and then you take the linear combination. This is the original function. So, this is a different orientation is given. We try to get the radial basis approximation of these functions, and these are the error which are given. Similarly, you have another function here, it is very irregular. I am not sure whether. So, this is very irregular picture. Okay, so, that can be approximated by using the fractal radial basis function. So, here all these different pictures are given. So, this last we have shown actually in the fractal case how we are getting the least error. So, here in the fractal case you can see this is 7.3 into 10 to the power minus 2, this error is very small. So, last part is machine learning part. Okay, so, in support vector machine they use the construction of hyperplane. Okay, so, so for the classification problem we need this SVM technique. So, I think everybody is familiar with that one, maximize this condition subject to these two conditions. So, that you can use the KKT condition and you can get the classification problem that can be written as +1 or -1. So, this is the classification problem. So, there you need a kernel technique. Okay, so, phi of x into phi of y. So, you can take the Gaussian kernel, in practice they take like that. So, in the machine learning problem we optimize this parameter gamma, which is given by 1 by 2 sigma square. Okay, so, that is why you can choose your classification problem very effectively. Okay, so, the similar things can be transformed to a different setting by taking its dual problem. So, I think most of the people are familiar with this part nowadays. So, in fractal kernel what we do actually, we take the Gaussian one. Okay. So, I need the fractal version of the Gaussian function. So, therefore, I need such type of Gaussian function because I have to do the separation. So, separation may not be smooth. So, I need such type of function. So, I got the fractal Gaussian function. So, you can see this is the Gaussian function. Okay. So, this is the fractal Gaussian function. So, if you need to separate the data by using such type of boundary, then this is possible. Okay. So, here I have shown you change the different parameters. So, you can get infinite number of different type of fractal radial basis function, that is in particular case in Gaussian case. So, here we use actually first we, because it is difficult to optimize both gamma and parameters of fractals. So, first what we did actually, we do the 10-fold cross validation for this value of gamma. So, that and also we fix the value of C there. So, use some program in Python and then you got the value of C and gamma, then you optimize the values of alpha to show the applications. So, these are the different kernels for our applications. So, here you take actually two data, heart failure and mammographic data for the classification problem, and similar all these data are available in the Kregel, and then this is the classical radial basis function. So, you can see in the fractal radial basis function. So, for heart failure it is giving better result, similarly for mammographic data this is also giving better result. Okay. So, therefore, one can use I have given only simple classification problem, we are doing for other type prediction and other things by using the fractal radial basis function. So, these are the references, mainly I took from the 7, 8, 9 these 3 papers. Yeah. So, thank you very much.
Thank you, Professor. Interesting talk, and I think giving that is theory and theory to the practice, right?
Yeah.
Because machine learning nowadays people, everybody talking, so behind this history, and then also how we use like modern type of technique to improve the machine learning algorithm. So, any question or any concern? Okay, so any question or any comments?
Sir, is there any error estimation regarding the classical as well as the fractal methods? Error estimation?
Error estimation generally if you give an unknown function, for fractal function it is implicit function. So, difficult to get the error. What we do actually, in case there is, we take the help of the triangular inequality. If the original function is there and f minus some classical approximation, then classical minus fractal. So, that is possible because we can get the functional equation and there I can get the error actually. So, we have different techniques are there how to find the error, but in practice, okay, so theoretically always it will be more than the existing error, but in the application you will find it is less because always use the triangular inequality, and the fractal case it is an implicit function, very difficult to get the error point wise. Okay. So, therefore, if you take directly, okay, if some data is there, function is there, you take the fractal function, okay, numerically you can estimate it and always you will get the better result, but theoretically it is always more than the classical result. Okay, numerically it will be less.
Sir, actually what is the real life application of the fractal function and a radius based function?
So, wherever you are using radial basis function, you have only single function, you do not have, you have to optimize only that lambda I. If function is given, you are writing linear combination of radial basis function with lambda j, you are optimizing the lambda j. In the machine learning problem, you are just tuning one parameter, you have only one layer. When you go to the fractal, okay, so here I am not told about the GPR, there is another parameter is possible. So, here you can optimize the values of alpha and optimize the bx also, base function. Here I am giving two more parameters. So, two more hidden layer is possible by using the fractal radial basis function. It is possible to another add signature, 3 is there. So, whatever you are seeing, if you are taking any natural phenomena, there also one can get the what is fractal dimension. So, when you are applying the this fractal radial basis function, here also you can match whether the dimension is matching or for qualitative comparison, okay, you get the what is the fractal dimension of the original phenomena. Then whenever you are applying to the fractals, you compare the what is the fractal dimension there. Okay, so then you check whether they are matching or not. Okay, this I think this research is in so it has not been done actually. I have not published the last part also. Okay.
So any
When you have random data, so we use that one. So scattered data, for scattered data I have said, for scattered data we started with a radial basis function. So therefore, when you have random data is there, you can use it. So that is a different way actually. We use Riemann other things, okay, fractal model to predict certain things. Okay, that has been done in a different context. Okay, so here I think all these are mainly here I have done for the classification problem. So for the prediction and other neural network part, we are doing it currently using this type of radial basis function. Okay, you will not find anything because this whatever I told, this is very much new, okay, in the fractal theory, which can be used in the machine learning.
okay, so I think we'll wind up this session, this talk now. So can we, of course, like the clapping, the motivating the researcher, right? Thank you. Thank you, Professor.
Thank you, sir, for that engaging talk. As a token of our appreciation, I would now like to invite Session Chair Professor Sanjeev Pereira and Dr. Sunita Chand, our HOD ma'am, to felicitate our speaker for today's session, that is Dr. AKB Chand. Can we have a round of applause, please?
Thank you.
Thank you, sir. Thank you, ma'am. So now we move on to our second keynote lecture of the session. The session will be presented by Dr. Bappan Ghosh. I'll just take a minute to introduce sir. Dr. Bappan Ghosh is an associate professor in the Department of Mathematics, IIT Indore. He completed his MSc from the University of Burdwan, West Bengal, and PhD from IIEST Shibpur, Havda. He worked as an assistant professor at NIT Meghalaya. Before joining IIT Indore, his major research area is applied dynamical systems and mathematical ecology. He visited France and Russia as a short-term researcher. He published more than 50 articles in the international journals. He also investigated several projects such as the early career, including the early career awards, core research grant SERB, metric SERB, Indo-French project, and many more. 3 students obtained PhD degree and 5 more students are working under him. He organized several academic events, including NetSciX 2025 conference. So the title for the session is Dispersion-Induced Additional Steady States in a Delayed Population Framework. Sir, we are delighted to have you with us. May I now request you to kindly take this stage and present the talk.
Yeah, hello. Yeah. I think I can keep it here. It's working, I guess. Yeah, it's fine. So, pen drive. How to stop this one? Yeah, someone can help me. Oh, a pen drive is given already. Yeah. Yes. Yes. Yeah, that's great. Okay. So, good morning and namaskar. Thank you for giving me this opportunity. Yeah, of course, I thank the organizer. Yeah. So, this is the title of my presentation. Dispersal induced additional steady state in delayed population framework. So, this work is deals with the how the dynamical system can be changed due to coupling or the population dispersal. So, it is more on the computational dynamics points of view. So, this is the overall content. So, first I will give a little bit introduction of the population ecology, what we really look for in the population ecology and how to model the population dynamics using differential equation, and then I will discuss what is the patchy model and the population dispersal, and then I use the delay differential equation to capture the dispersal delay and some of the conclusions. So, I generally skip the mathematical part, but I will briefly discuss the tools and techniques used in this work. So, first of all, population ecology. So, population ecology is a very special branch of the biological sciences where we discuss about the growth of the population, size of the population, their extinction, their behavior, or even how the different trophic level or species can interact with each other. There may be different types of interactions such as the cooperation, maybe the competition, maybe the predation, but in this particular topics we will discuss more on the predation processes. And then not only that, also that there may be some influence of the abiotic factors in the environment where the species behavior can change, they can disperse from one to another places and so on. So, these are the main key informations what we look for in the population ecology. So, this is one such complex food web, where food chain and food web there is a difference. That food chain means the arrow will be in the one direction, like one species to another species. So, if you have multiple food chains meshed together, then it will be the food web. For example, this is the primary level, this is the resources, okay, and then this is the primary consumer level, and then there will be the secondary consumer level and so on, and this is the top trophic level. So, even the these are kinds of one population, you can say one population, it does not mean that only one individual. So, this is the group of population, this is another group of population, they have the same resources of course, but they are in the same trophic level, okay, because their food habits are the same, and then the next level and so on. So, they can be considered as the herbivore species and then carnivores and so on. So, it is very complex, you can see from the structure. Even in the real ecosystem, you can have the thousands of species in a forest ecosystem and so on. So, it is very complex to understand the overall dynamics of an ecosystem, but and also suppose if you remove one of the species or you can give more nutrient to one of the species, then what would be the overall impact on the other trophic level. That is also one theme of population ecology to do research. So, now the thing is that how there are many types of competition, as I mentioned, that maybe the interaction, maybe the competition, maybe the cooperation, or maybe the predation and so on, but here we will be discussing mostly on the predation. So, how one species can consume other, and for us, especially as we are from mathematics background, we try to model some of the ecological systems in the small scale to understand the impact in the generic sense. Okay. So, how to model such type of phenomenon, at least the predation, from mathematical point of view. So, here we generally formulate the differential equation. There can be many other types of modeling like the statistical modeling, totally simulation modeling, maybe one can have only data and then can use the machine learning, or one can have the graph theory to understand the transportation of the energy from one node to another node and so on, but here we will use the differential equation model. So, once we talk about the differential equation model, then we need the state variable, okay, x1, x2, x3 and so on. So, here what we will be doing here, suppose you have the simplified situation, the prey population and predator population, then you need the and we want to know how they are growing over time. So, we need the two state variable, one of them I am denoting by n, other one is the p. So, n stands for the prey population and P stands for the predator population, that is the predator is the consumer, and N can be considered as the resources. So, predator consume the prey. Now, how they will consume the prey? So, generally one such formulation is that the one predator, what would be the total consumption in per unit time, that we look for. So, that is called the functional response, and this functional response one can think in this way that A into N, this means the A is the capture rate and then N is the number of prey. So, if the number of prey is more, then it will be a linear function, it will increase, okay, linearly, but once the number of prey is sufficient and there will be some fixed number of predator, then predator will be saturated. So, if the number of N is less than some threshold, then it will be linearly increased. Then once the prey is more than the N naught, so you have the sufficient number of prey, then predator cannot consume too much, and then it will stop consumption, it will continue only N naught in this way. So, it will be kinds of the straight line, okay, inclined, then the fixed one such line. So, there will be some kinds of smoothness issue at that particular N equal to N naught. So, this is the one type of functional response. This is called the type 1, Halling type 1, which is introduced in 1964 by C.S. Halling, and but later time he also introduced another types of functional response, that this is in this form where you can have the handling time also, that is after catching the prey you need certain times to kill it. So, if the killing period is h unit time, then it will be a n by 1 plus a h n, and you can see here also, for if you have the more number of prey, then again the maximum capture rate will be a. Actually, if you divide this one by n, then the limiting value will be again 1 by h in this case. So, again it is kinds of fixed, but this is actually the smooth function. But here in this both the cases, you can see that there is no involvement of the predator in the functional response. So, this is the maximum, the per capita consumption rate by one predator, that you can think the number of total prey consumed by one predator per unit time. But you can have other type of functional response. This is called the Beddington-De Angelis functional response around 1778. So, here the predator density will be also incorporated in this form. So, it has all the functional responses having the mechanistic derivation by certain law. It is not, for example, this one in some sort you can derive this one by the mass action principle of chemical reaction. So, many population models are described based on the mass action principle, especially the Lotka-Volterra type model. So, whatever I am assuming, it is not total the assumption, it is based on certain principle. So, this is another one, that here also you can have the mechanistic derivation for couple of pages to derive this one, but the point here I want to highlight that it is similar. Suppose if you do not consider the predator population, it is the kinds of Halling type 2, but you can introduce this Beddington-De Angelis functional response to incorporate the predator interference. Predator interference means if the number of predator is also more, then there will be competition among the predators themselves. So, then the overall consumption rate may be reduced, okay, per predator. So, these are the all types of functional responses, and here we assume that the prey and predator, they are uniformly distributed throughout. So, it is a homogeneous populations. Then you can have other type of population where you can have certain kinds of species, prey species who are in a group to defend the predator, and this is introduced by Kozner in 1999, and now this is also the functional response where the prey and predator both are involved in the functional response. So, NP and NP. So, this has certain meaning, the H has the same meaning. Here C is the fraction of prey killed per encounter per predator. So, this is different kinds of functional responses. So, it depends upon that what type of functional responses works for particular species. But here we will be discussing more generic information, not a particular case study. We want to know the computational dynamics in this presentation. So, what with the questionnaire type functional response, there are very limited literature, but this is one in 2018, that this is the ordinary set of ordinary differential equation. I want to know the rate of change of the population. Okay. So, if we are able to formulate the rate of change of each of the population, then we can estimate the population at certain times. So, this is the kinds of, you can think the Lotka-Volterra model. So, here you have the logistic equation, the prey can grow by themselves, they are the autotrophic species. So, they can take the nutrient from the environment or water, soil and everything, and then they can grow by themselves. But the predator, they are the specialist species, they completely depends upon the prey. So, there will be some consumption of the predator. Okay. So, this is the consumption process. So, this I mentioned that this is the functional response. So, one prey can consume this many number, one predator consume this many number of predator per unit time. So, you have the p number of predators, so it will be multiplied by p. So, this is the negative feedback, and then this negative feedback will be converted into the predator biomass, or this energy will be converted into the predator growth. So, this is alpha into the same functional response is available here, only difference is this alpha. So, alpha is the called the conversion coefficient. So, whatever you have consumed or energy you have the lost by the prey population. So, the whole may not be converted into the predator biomass. So, this is some fraction will come into the picture. So, this is the called the numerical response function. This is called the numerical, this is the functional response. So, these are the proportional to each other in this case, but it is not always the situation in different other types of model, and this is the mortality. So, in natural way, due to the age they can. So, this is the simplest framework, and in this simplest framework this paper have discussed a lot of kinds of mathematical bifurcation, okay, including the saddle node, transcritical, and some of the harvesting problems are discussed. So, I do not discuss this one. So, this is the one, but the interesting thing is that if you have the Lotka-Volterra type, means it is actually n into p, this is the total negative n into p only. So, this is called the Lotka-Volterra type model, and in Lotka-Volterra type models you have the only one positive fixed point, one positive fixed point. So, what is the meaning of positive fixed point here? Positive means the each component will be positive, that is the prey and predator both can persist. Now, if you have the type 1, so for type 1 functional response you have only one fixed point, but if you have the type 2 also, as I mentioned earlier here, type 2, then also you have the only one such fixed point. But this is the one model where you can have the two fixed point, and one of them, if the fixed point exists or positive equilibrium, then there will be two positive equilibrium, okay, always, or no positive equilibrium. So, these are the two positive equilibrium, and this one will be either stable or fully unstable, that is the either source or sink. But this one will be also unstable, but it is actually saddle, okay, it is saddle. So, at most two equilibrium can exist, and this one can be the stable node or stable focus, or maybe unstable node or unstable focus. So, the model I have discussed, it is actually non-spatial model, okay, that is the population are uniformly distributed in a single location. Okay. Now, if we consider the spatial extension of this model, like you can have the generally the prey and predator are not restricted in the one space, they can be lived in the fragmented places, and then there will be some population movement from one place to another place. Then what would be the dynamics? So, keeping these points of mind, that because the movement is really important for all the species, for us also we are moving from home to institute and going back and going to the market and here and there. So, all the species they need to move for different purposes, maybe for the food searching, maybe for to avoid competition, or maybe even for breeding, species can move from one to another place. Even due to environmental change you need the movement, or maybe due to the predation you move from one place to another place, and prey can move to their safer place to avoid predations and so on. Even in the fishery management, you can have one open zone for fishing, other one will be preserved for their safe growth. Also in the biological pest control tactics also you need the such kinds of environment where the population can move in the different location or patches. So if you model such type of phenomenon, then it is called the patchy model. Okay, it is called the patchy model. So you need more than one location. So this is the one such situation that where the fish can migrate from marine to the fresh water for the safe breeding, and then later time again they can return back to the marine again. So this is the previous one is the species movement, but even the seed can move indirectly. Okay. So for example, when species are moving from downhill to uphill, then the seed also will move during the summer season, and in the autumn seasons even the seed can move from the top hill to downhill. So migration happens for many species, not only the biological species, for other types of species such as the objects such as the seed. In fact, that is also will be the biological species in some sense. Now we really want to know that what are the distinct dynamics we can obtain if we impose the spatial structure in our previously non-spatial model. For example, in the spatial non-spatial model you had the two fixed point. So here the number of fixed point can be changed or their dynamics can be changed. So this is the one such things. Even when the species are moving from one place to another place, you need certain time. Okay. So the population what you can see right now in this place, they cannot be the actual population of the particular subpopulation, but some of the other population who started their journey from the another location 5 unit time before, they also can be accommodated here now in the current situations. So there will be some kinds of dispersal delay as well. So this is the non-delayed model. So here you can see I have taken the prey and predator located in one patch, only one location, but you can have another location where you have the same species prey, but the population subpopulation I am denoting by N2 and P2. So they are in their isolated patches. Now you couple them through the dispersal. So this is called the dispersal term, where the Dn into Dn, this is the dispersal rate for the prey population. So the prey population here left Dn N2 amount, and which is now available in the first patches. Okay, and the population subpopulation N1 which are living from the first patch can be added into the second patch dynamics. So in the same way you have the predator population's growth also dispersal. So now due to this dispersal, whether our dynamics can be changed. One thing I would highlight here, that you can see that all the parameters are same in both the patches. So one may think that overall there will be no change because the both the population numbers are same, their capture rates are same and so on. But due to this dispersal, so here we will distinguish two terminology, that one is symmetric equilibrium. Symmetric equilibrium means you have the N1, P1, N2, P2. Okay, because you have the 4 state variable. But if N1 star equal to N2 star and P1 star equal to P2 star, then we say that symmetric equilibrium. Otherwise it is called the asymmetric equilibrium. Now if you have in the isolated patch, definitely in the isolated patch you have the N1 P1, and in another isolated patch you have N2 P2. So if they are the symmetric N1 P1 and N2 P2, so these are the equilibrium in the isolated patch, then in the coupled patch also this equilibrium will remain the same. This will persist because of this homogeneous patches, because this will have no role, because N1 this value and this value will be the same at equilibrium. That's what we assume. So this will be also the equilibrium, but we look for the asymmetric equilibrium, because These are the additional equilibrium, if it exists or not, that we look for. Okay. So, this is the main motivation, that whether there will be other additional equilibrium existing or not, what is the role of those equilibrium in the population ecology, what will be their stability, and whether multi-stability can occur or not. Because in the very first model, non-partial model, we had only one equilibrium, and either it will be stable or maybe you can have unstable or kinds of stable limit cycle. But here we can see that there will be change. So, these are the straightforward way we have calculated the equilibrium, but for the 3 different cases, dn greater than 0, dp equal to 0, dn equal to 0, dp greater than 0, and both of them greater than 0. But for these two we have the analytical expressions for all the equilibrium. Here I am showing the numerical results, but for this one we do not have the analytical results, only numerical results. But here you can see that here you have again the 2 equilibrium only. So, in the non-partial model also you had the 2 equilibrium, but here you can see in this situation you have even 6 equilibrium, okay. So, some of them are actually the asymmetric and some of them symmetric, but if asymmetric equilibrium exists, then they will be in pair, okay, they will be in pair. For example, you can see that this is the asymmetric equilibrium because this value and this value not same, and this value and this value are not same, okay. So, this is the asymmetric equilibrium, but their swipe version also will be the equilibrium because of the homogeneous patches between these two, okay. So, here you can see that, yeah, symmetric part I lost here somewhere, how to explain, just wait, somewhere I missed here asymmetric part. Well, oh, okay. So, these are the all equilibrium, but their swipe version also will be an equilibrium, that version I did not write here. So, you can see that if you change this one between these two, if you exchange, then also they will be actually equilibrium, that I wanted to say. So, you can shift these two and you can see, exchange these two, they will be also equilibrium. But here this is another asymmetric equilibrium. In this particular case, these are the symmetric pair. Symmetric pair even exist in the isolated patches, but this is the asymmetric situation that we calculated perfectly, okay. It is not the numerical results, but exact numerics. So, what I wanted to say here, that finding the symmetric equilibrium is easy. From the non-partial model you can do it, but for the asymmetric case you cannot get the exact value, because in numerics you have to solve the nonlinear equation using Newton-Raphson and all, but here we are able to show that exactly this value will satisfy the differential equation. So, we are sure that this will be one such equilibrium. Now, one results that non-existence of equilibrium. So, if you consider dn and dp, they are very large, then although initially you can have the existence of equilibrium, asymmetric equilibrium, but they will disappear later, okay. So, for stability we have done the same way, traditional methods, the characteristic polynomial, we calculated it from the Jacobian matrix, that is very standard, and then we calculated the stability. So, one such result is that what I wanted to say, that in this particular case when dn greater than 0, dp greater than 0, so this is the with respect to n star how many equilibrium we are getting. So, this is the blue one is the symmetric equilibrium part, this is the stable, blue means stable, this is the asymmetric equilibrium which exists even in the non-partial model. So, they will exist, they will not change at all due to the dispersal at all. But you can have two more asymmetric equilibrium, okay, which depends upon the dispersal rate. So, they are changing with dispersal rate. But as I said in the theorem, that if you go beyond certain value, then these two equilibrium will disappear. So, you will be left with the unstable situation. So, you can have the stable limit cycle in the system. There is no fixed point at all, stable fixed point for larger delay. Now, this is the another situation that where dp greater than 0 only, and you can see you have multiple equilibrium. So, this is the one equilibrium which is always symmetric, exist stable equilibrium. This is the unstable which is also existing in the non-partial model, but there are many modes, like here this is one, this is the 1, 2, 3, 4 and here 5, 6. This Joule version is like that. So eventually here you can see that this is the one stable equilibrium, but you can have the one more, and here from here, that is this one, also one more. So 3 stable equilibrium, that is the tri-stability occurring here, which is not possible in the non-partial model. So here we can have the tri-stability. So this is the something new. This is the time series I am not going to discuss. And now the situation where you can have the both of them are greater than 0. Then you have the more complex dynamics. So here you can see that the only one stable equilibrium, but here you can have the 3 stable equilibrium, and for larger delay again the monostability occurring here, only one stable equilibrium, then again you can have the tri-stability, then again you have the bistability. So you have the transition due to the dispersal, monostability, tri-stability, monostability, tri-stability, again bistability, and for larger value they will again disappear, as I mentioned in one of the theorem. So we didn't show this particular part, and everything will be unstable later. So these are the some of the scenario where in the non-partial model have one stable coexisting equilibrium or stable coexisting equilibrium. But suppose in the non-partial model you don't have the stable coexisting equilibrium, what will happen? So this is the situation in the dn and dp. In the very beginning you can see that there is no stable equilibrium, but if you increase dispersal in the this side and this side, both the dispersal, then this is the zone where you have the stable coexistence of the equilibrium. That is, this says that in the non-partial model you may have the population extinction, but due to dispersal can help to recover populations. Okay, so dispersal is essential for population recovery. So this is the something new which never happens if you consider the type 1, type 2 functional response and other types of, this is very special type of situation where you can recover the population. Now this is the last part. I have another 10 minutes, 5-7 minutes. Another 10 minutes, okay, then I can go little slow. Well, so now we will be considering the delayed dispersal model. The same model, I am considering the delayed dispersal. What is the meaning? So delay, whatever the action happening, its reaction may take some time to reflect. Okay, it is not instantaneous. What we have considered in the previous model, we didn't consider delay, that is the dispersal happening instantaneously. Dispersal happening instantaneously means the patch location between two patches, their distance are significantly small maybe, and population can move very frequently. There is no delay between, the travel time is very small. But if there is a travel time, then there will be the model will be different, and we capture this phenomenon with the delay differential equation. So what is the meaning of this one? Suppose the current situation, the N1T, whatever the current population the prey is available, they are leaving some fraction dn into dn1t. So t is there. But what is the meaning of this term? This term means this represents that n to t minus tau 1 is some positive quantity time. So this means that the population measured at the estimated at the time t minus tau 2, that is not at the current time but some previous time. So this previous time population, this means the population which left the patch 2 in t minus tau 1 time before, they are now available here. The population which is leaving the second patch, so this means actually n to t, n to 2, they cannot move here immediately. They will be moving to the first patch in tau unit time later, So this is called the delayed dispersal model. So we want to know now that due to delay what are the possible dynamics one can obtain. In the previous case only we changed the dispersal rate, now dispersal rate and all will be fixed, but due to delay how the stability can change. So we define different kinds of stability scenario, okay. Some sort of like we have proposed this type of definition, but of course in the literature stability switching is always available, but the others not. So we obtain many dynamics, that is what we propose to give different names, and this is available in this particular paper, mathematics and computer. So this definition, so this paper does not deal with this patchy model at all. This paper, this is the submitted paper under revision, revised version, the part I am discussing, but this is another previous paper. This is also deals with delay but non-partial. So here stability invariance means you have the equilibrium points, now it is stable without delay. If you change the delay, whether the stability will change or not. So in this case stability never can change, okay. Then such an equilibrium is stability situation, we call the stability invariance. Stability change means the equilibrium when no delay is stable. If you are increasing delay, there will be some threshold up to which it will remain stable, after that forever unstable. This is the stability change, only one change, there is only one transition. Now next one is the stability switching, more than one transition, like the stable, then it become unstable, remain unstable, then become stable, then unstable, stable, unstable, but after finite number of times it will remain unstable. So switching. Instability invariance just opposite of stability invariance, start with the unstable equilibrium where the delay can change the stability. So no change means the instability invariance, okay. Instability switching start with unstable equilibrium and then remain unstable, after that stable, then unstable, but eventually it will be unstable, like this, okay. So these are the all four definitions. So many papers they discussed only one of them, or maybe maximum two, this or this, or maybe this or this, but in this paper we obtained all five together. That was the only innovation or some kinds of new information you can think. And most of the work they do not consider the situation where the fixed point will be stable without delay, but we have covered this part as well. But in this case we want to know you have the multiple equilibrium in the partial model without delay. Now both can change the stability, or one can have stability switching, other can be instability switching, or maybe both of them can maintain the stability without any change. So you have the many permutation combinations. So some of them we have discussed here. We cannot say that how many maximum number of such situation can happen, we really do not know, but this is the one such first such type of kinds of work. So we have investigated some of them, but in this case I will discuss only one of the cases, only one, the more interesting possibly. So there are many limitations as well in the current situation, that we consider two delay, but we are not varying two delay simultaneously. That needs more mathematical analysis, but we have done one of them are varying, other one is fixed. And in this presentation particularly I will consider this case, that tau 2 greater than 0 and tau 2 equal to 0, tau 1 only greater than 0. So the challenge is that in this case the characteristic equation looks like that, and you can see there will be the exponential term, and lambda is the unknown variable, that is the eigenvalue you want to look for, we have to calculate. Now once you have this type of transcendental things, then you cannot say that number of equilibrium will be 4 or 5. So you can have the even infinite number of equilibria, eigenvalue. So in the very beginning tau equal to 0 you have the 4 eigenvalue. The moment you increase tau, all the eigenvalue will be created in the left half complex plane, and later they will transit from left half complex plane to right to make the equilibrium stable to unstable. So this involves a lot of complex analysis things. Some of the information are available in the paper or any of my previous other paper. So if the bifurcation happen here, again another idea that here that in such type of delay model is called actually retarded delay differential equation, and here you do not have the transcritical saddle node pitchfork line bifurcation, okay, because such type of bifurcation requires one of the eigenvalue has to be 0. But if tau equal to 0, then you cannot obtain such type of 0 eigenvalue at all in such type of delay model. So only bifurcation can be Hopf type. So we assume lambda equal to iota omega. We look for such type of eigenvalue for certain delay threshold if possible. That's what we have done. There are a lot of calculation and all, and for this one you can have maximum 4 such delay sequences, okay. Tau 1, one such sequence, tau 2, tau 3, tau 1, there will be 2 such sequences, and corresponding to tau 2 there will be another 2 types of sequences. Now for one numerical simulation I will try to make you understand this fact. Correct, okay, I am about to finish. So now let us consider this is the case where you have the 3 equilibrium, okay. The symmetric equilibrium is stable, asymmetric equilibrium will be in pair, okay. So if you know the stability of one, you can know the stability of the others. So they will be unstable, okay. For stability case, for this equilibrium I am discussing that you have, those are the sequences. What is the meaning of red? Red means that at this particular value of delay, a pair of eigenvalue will move from C minus complex plane to C plus complex plane. This means you are actually making the equilibrium unstable. What is the role of this blue? Blue is stabilization. Like the eigenvalue pair which went to the C plus plane, they now return back to the C plus plane via the imaginary axis, okay. Then the equilibrium will be stable. So these are the role. Now what is happening? See the distribution, okay, distribution. The first member is this one. So initially your equilibrium was stable. Stable to up to this level, it is stable, this value. The moment you are increasing delay, a pair of eigenvalue will cross to the C plus plane, then equilibrium will be unstable. So next value is this one. Then that pair will come back to the C minus plane, and in the C plus plane there is no eigenvalue positive real part, so equilibrium will be stable. Now next it will remain stable up to this level. Then the moment you increase delay, after that the equilibrium will be unstable, but again it will come back here, okay. But beauty is that you can see these two are now consecutive. This value is bigger than this. So next when you are increasing, the equilibrium is unstable, so 2 pair in the C plus plane, but next candidate is this one, then again another 2 pair will go to the C plus plane. So you have the 4 pair, and the theory is in such a way that the distance between, actually those rates will be frequently occur on the line. So more and more eigenvalue will cross and go to the C plus plane rather than bringing them back by the blue member. So that's what it will remain unstable. So this is the situation. In the same way, for this one you can have that you are starting from unstable, then because of this one it will be stable, then unstable, then stable, unstable, it will continue. In fact here luckily we got the 40 such situation. So this is the one such graph where you can have initially stable equilibrium, so stable, one of the equilibrium, then it become actually, this is the unstable equilibrium. When you have this circle, then it is unstable situation, and then it is stable fixed point, then unstable stable. So you can see that both this is for one equilibrium, this is for the another equilibrium. So you can see the 4 classes of tri-stability happening, okay. So you can see this is the limit cycle bistability. Here you can see limit cycle and fixed point bistability. Here you can see unstable fixed point and stable fixed point bistability. So you have one more symmetric case, that's what tri-stability. So many bifurcation and multi-stability can happen. So there are many such other situations I do not discuss. So previously stability switching and instability switching pair bifurcation happening. So this is the main conclusion, that you see that dispersal event can induce new asymmetric equilibrium which never possible in the non-partial case. Multi-stability is very much prominent there, tri-stability mostly happening without delay, and population even can recover. So dispersal is really essential for population recovery, and 4 distinct class of tristability occurs, but this tristability is due to delay. Such type of tristability not possible in the non-facial model, and both the equilibriums having the switching situation. One is stable switch, other one is unstable switch. So those are kinds of computational dynamics and sort of addressing some generic information on the population ecology. So that's all for my side. So thank you. Some reference I have given 2-3. There you can see many such books on the delay differential equations. So in the facial model in delay, there will be very limited resources, and I'm sorry that it's not published yet. So you cannot get the resources. Anyone is interested, I can share if needed. So please, if you have certain questions and suggestions.
Yeah, thank you, and very interesting and informative talk. Basically, this population dynamics is a very old subject area, and so we know like that these predator-prey models are now very popular in the most of the areas. Resource allocation and various places are in place. So it's very informative talk. So any questions or any suggestions? Yeah.
Yeah, please.
Thank you for your presentation. I was just missing the beginning, but I was catching some of the, you total stability exchanging in your last couple of slides. But what is the parameter we can fix so that we will always have the stable? Is there anything you can switch up, fix the parameter? Okay.
Yes, wherever you are getting the stable, then you fix the parameter. You don't need to move. If certain situations permits that the ecosystem is stable, then you set one of such parameters. So the beauty of the mathematical model, in some sense you can think you are able to explore all possible cases, but all possible cases may not be feasible in the ecosystem. But as mathematician, we do. But it may, among all of them, maybe 2-3 cases hardly will fit with real ecosystem. So that particular parameter you can fix it and try to explore the other type of dynamics.
Why I raised this, that usually in like fluid dynamics, etc., when you look stability, we look one side is stable and other side is unstable, right?
Correct.
So once we do that, okay, it is increasing, that means we know that this is the criteria, after which it will increase the instability. So we may
avoid.
We can avoid that. So as your case is exchanging, that's what will keep curiosity that how to have always only stable. So because it is exchanging, because the
Correct.
Is there any fixed criteria?
There is no criteria is coming from mathematics that based on that you can decide your stability zone or interval. But you see the most of the people, they don't like they like the stable, correct? But not the unstable. But unstable means kinds of oscillations. But oscillation is most important rather than stability. For example, in the heartbeat and all, if you stop the instability, then all your oscillations will stop. All biological phenomena are based on the oscillations. Even the chemical reaction, your daily life, sleeping, that is also oscillations. It's completely oscillation. So if you stop the oscillations or instability, then you have to sleep only, or you cannot sleep at all. So oscillation is most important. Although in some sense oscillation is harmful where you have the chemical reaction in the apparatus, you have the high oscillations, the apparatus may be broken or something. But in general, oscillation in biological aspect is much essential than stability.
Yeah,
so we cannot avoid it.
Yeah, specifically in the ecology system, oscillations are important because when the outside things can change, oscillations can occur. I think a nice example is COVID-19 also. You realize like that those are oscillations, right? So we cannot ignore like the oscillations especially in the ecology and the epidemiology type of like things.
So for example, even the predator that consume more prey, then they will be more in number, but at certain level your prey level will be less, then predator cannot get food and they will die out. So their level will be less. Then again the prey on the other hand will grow, then again more consumption, predator will grow, prey will, so these oscillations will continue in predator-prey system. Yeah.
So I think considering about the time, so we'll stop in the now, and so we'll appreciate the talk, and then as usual way.
Thank you.
Thank you, sir, for the enriching and informative lecture. May I request Professor Sanjeev Pereira and Professor Satyaranjan Mishra, sir, to kindly come forward and felicitate Dr. Bappan Ghosh.
When did you come?
Can we
Now?
have a huge
Yeah,
round of
now?
applause, please?
After the end. Yes.
Yes. We'll have a 10 minutes tea break. You can just go and come back.
Okay, good morning, welcome again. Uh, Now I introduce to today's third speaker, keynote speaker, Dr. Jitendra Kosik. Dr. Kosik is an associate professor of statistics and business analytics at Symbiosis Pune with around 15 years of teaching and research experience. His research interests span statistics, business analytics, operation research, data science, and research methodology, etc. He has published many research articles in reputed journals. He also serves as associate editor of Curious Journal of Computer Science Springer. He has been actively involved in academic conferences, research guidance, FDPs, and scholarly activities, and has been assistant chair at several international conferences. So please join us. Please give me a huge round of applause to welcome sir.
Thank you. Good morning to all of you. My core area is inventory modeling, the part of applied mathematics. I have a few command over data science in forecasting and predictive analytics. In this paper, total overall supply system is dependent on the three things. One is the manufacturing, second one is the inventory, and third one is the logistics. So inventory is second part. So I am working on inventory modeling. I developed many models. This paper I developed for the pharmaceutical industry. Problem in pharmaceutical industry, most of the time what happen that your medicines they get expire after certain time period, or sometimes it's observed that some molecular value get diminished after that certain time. After that certain time period, then molecular value get diminished.
सर रिकॉर्डिंग के लिए तो चाहिए
रिकॉर्डिंग के लिए चाहिए लाओ. अच्छा. अब ठीक है. For the final consumption, the problem is that the final consumption, the quality of the products always required, especially in the case of the medicine, then otherwise the problem arise. The second problem is arise that how much item to be stored by the distributor and hospitals, because sometimes in hospitals the sometimes that medicines available much and sometimes it's not available, and especially if it's related to the life saving drugs, the problem is arise. Fourth problem is arise that sometimes few things playing very significant role, such as price of any item. If the price of any medicines are higher, it can be inflamed. They can charge any price, then the problem is arise. For the customer point of view, we need a controlling factor, that is denoting as J in my study. And another factor is that sometime if the price is high, but the quality is up to a mark, and is a goodwill also connected with it, like that Cipla company, Mankind company, their product. Suppose that price of any company is X and they're giving delta X, so people prefer them. So in this situation, how much item to be stored? What would be the replenishment time period? What will be the optimum price? What is the selling price? How much to store? When to reorder? So totally supply chain affected by these things. So I am discussing these things here. I considering RAM type, the trapezoidal type demand function, I explained that the trapezoidal in the first stage, when the demand are very high in the starting, especially in the seasonal items, demand are very high. Then after certain period become constant, then decline. Seasonal demand we can understand that like demand being right now, dengue cases will increase. So in the first case demand will increase. Then after that a certain level becomes stable, and then after a certain period then atmosphere change, it get to decline. So I considering the trapezoidal demand here. So I find in my study, is just a brief study, there globally 8.5 trillion, approximately 1.98 of the world GDP dependent on that healthcare and especially on the medicines. So annual turnover is 1.4 trillion. So pharmaceutical wasted 4 to 9%. So this is a huge loss, and that extensive loss just motivating me to write a research paper on it. Then after that I find 37.5% medicine out of the stock, means item is available, nobody purchased it due to that reason. So proper delivery also plays a very important role. And in Chicago, that healthcare department proclaiming that $1 million medicine get wasted due to the absence of this mathematical model. Then household savings spend approximately 60 to 80% on medicines, and if they waste it, so it's an extensive loss. What is the difference? Literature. In the traditional model, we find that deterministic statistic demand, real pharmaceutical demand over the lifespan is dependent only on time. And some model I find that from Aditi Khanna, I seen that she write a paper only on the price. But the important thing is that in this study, price and time dependent, both of the parameter I consider. And furthermore, the deterioration item, that is a deteriorating item dependent on a particular time period 0 to T1. Important thing is that I consider a dual price factor J and K. So this is research question. We find that what is the optimal replenishment period, what will the optimal selling price of item, how much to store, when to sell out, this type of the question. And similar type of the question for the customer side also. Which item need to be stored, when to store, what need to purchase. So few researchers, that Uthay Kumar only and Rastogi Singh, they write few papers on it, but they consider only the time dependent demand function. In this study, I consider price and time dependent and dual price factor. So as I already tell you that suppliers, manufacturer, distributor, retailer and customer. So we focusing on retailer pharmaceutical thing. This is trapezoidal demand, when the demand is increased in the starting of the season and then become constant, then the decline, the change in the demand due to change in the atmosphere. So that's the practical application applied as a trapezoidal demand. The important thing is that price enters the twice, the factor J and K. The factor K is that customer brand preference, and factor J that influence the price. In this I consider T1, T1 is 45, means that this is T1, this is T2 point, and when the demand is going to finish, that is T3. So I consider it weeks, in the number of the weeks. Here few symbols which I using it. A is a fixed demand, B customer preference, change in demand, J is a parameter influencing, K is another customer preference, R is a shortage allowed only once a time. This. In this study, I consider the partial backlog shortage, because sometimes the shortage is there in coming to the existence. When the medicine is not available, we contact it to the another suppliers to fulfill the demand. And deterioration also controlled under the preservation technology. In this study, I applied the preservation technology also, which enhance the shelf life of the medicines. So TM, that's the shortage starting period. C is purchase cost, and these all are the cost. So deterioration without replacement, trapezoidal, price, time and dependent demand function, profitability constants, preservation technology, partial backlog with discount to the loyal customers, and it is a single items I consider for the instantaneous replenishment. This is the demand function, A plus BT, P, J plus K. J is influencing factor, K is customer preference, it is preservation, which controlling to the deterioration with applying the preservation technology like refrigerator, packaging or any other food. Then deterioration can be controlled. It is lies in first phase starting from the 0 and ending to the T1. Small t is replenishment period when we reordering the items. Then after that we come into the existence of the second phase, similar things. Now it is starting from the T1 to T2. Then this is T3 phase where it is going to decline. The In this situation, is a sales equation I put that is a sales revenue. It is starting from the 0 to T1 and total demand, holding cost, backlog revenue, purchasing cost of the items we consider. This is profit function, total sales revenue plus holding, then minus holding cost, and that revenue we earning from additional sale during allowed shortage, partial backlog shortage. This all are the stage. We maximize the profit. The two decisions variable there, price and time, and other are the variable. The two things are important. One is a demand parameter and others are the variables. Demand parameters are known who deciding the factors, and the deciding the factor is what? Price and time. Other variables are what? J, K, M, and other variable which can influencing the demand but not deciding the main parameters. So, dual pricing plus preservative technology applied in this. So, that is the reason their deterioration, control and shelf life increase of perishable items. In second case, no preservation technology allowed for the comparison purpose point of view. In third case, only a single factor, J factor considered, K factor not considered, means that goodwill of the company, goodwill of any particular medicines, it is not included. So, what are the impact there? Case for particular cases are there. Sometime what happen then, replenishment time period get changed, sometimes selling price get changed. So, what happen if the replenishment time period can change? So, we just observing in these 4 cases for the study point of view. Here we find that we just differentiating the profit function with respect to the time and then respect to the price, because those are the parameters, demand parameters. Then first derivation equal put to 0, and then after that we finding the point, which point is better point for that we finding, and then applying the second derivation and putting into the second derivation and finding either it is a maximum or minimum. It deciding is the profit function is concave or convex. The convex situation is arise when we are discussing about the minimum cost of any item, and concave condition is described when we are just finding out the maximum profit per unit or maximum point where the profit will be maximum to the retailers. And if the retailer get the maximum profit, it directly influence to the supplier also, because at that time they can provide the more orders well in advance. So, the wastage of any items it can control. Second order derivation we put it, and we finding that if the value is negative or value is positive dependent on that thing. In this study I considering concave, so value should be the negative. So, we verify it and then applied that method. Sometime it gets failed, so applied another method, another value till we finding the maximum profit. Because in operation research two things there, the optimal solution and corner solution, lot of the solutions are there. So, we choosing the optimum solution where the profit are maximum and cost are minimum. Fine. So, the condition of the concavity is derived in research paper, it is derived by manually also. After the second derivation we derive it manually, and we finding this value is a negative. I applied to another optimality condition, that is a Hessian matrix approach. First time I applied in 2023, after that people generally applied it. The Hessian matrix approach I applied there, and it is showing the joint concavity with respect to the price and time. And then there is the tooling like mathematical numerical example, other toolings also, graphical methods, concavity conditions, their value, these all are describe your functions is that demand function is concave or not. So, this is either is a profit function with respect to time 0, we finding optimum time, this profit function price, then concavity I find. Here the per unit maximum profit retailer can earn through the proposed inventory model, and this is theorem. This is calculated manually, sir. After the second derivation we finding condition, after second derivation we derive the formula manually, and after that we find this condition. It should be always less than 0. So this is Hessian matrix approach. Because it's 2 by 2 matrix, so it should be greater than 0. The first condition of the Hessian matrix less than 0, and second one is greater than 0. It tells us another optimality condition. This is I find from the study. Case 1, full model, per unit profit per cycle, that was $23.86, and then vice versa I find. So purpose of that, when we applying the preservative technology and dual pricing factor, we getting additional profit for the retailers, and that additional profit can convert direct additional profit per cycle to the suppliers also. Furthermore, what we find, the optimal replenishment period, that 74, maximum profit getting in phase 2. What is the reason? In phase 2, when demand get stable, at that time period, no other demand there, holding costs are less, and generally they purchasing the item more, orders replace more. Optimal policy is that maximum profit we earning, and optimal selling price will be this. Important question is that if the optimal selling price increase, then customer to the other distributor or other company. If it is less, then price floor be disturbed. It would mean that your selling revenue is less than by your purchasing item cost per unit. So it is directly convert to the loss. So we have to be focused on that optimal selling price. So important factor there, optimal selling price, replenishment period. So we can here add additional amount accordingly. Then after that, we know that when to reorder the item. It is an important factor to avoid any type of the partial backlog problem or shortage problem. The retailers, they reorder the items before the finishing. So it play very significant role. So from the first case, when the dual price I applying with the preservative technology, I find that this is a benchmark study. Then per unit profit in phase 2 I got maximum profit, and in phase 1 very less profit, and phase 3 profit is there. In phase 1, why the profit are less? Because people just are starting ordering. In this situation, they ordering more, and initial inventory are more there, and backlog order are more there. Then after a certain period, people not giving the backlog orders. So that's why we not ordering to supplier more items. So profit getting loss, means diminish at that time, and vice versa. And it is saying that when the deterioration level is increased, profit decrease into the same manner. It shows that the deterioration play very significant role, and deterioration cost also high as diminishing time period start. So after that, when the deterioration rate is high, profit get loss. So it would mean at that time, what is the optimal time? When the deterioration is 0.4, we have to reorder at that point. And what the strategy can apply that the deterioration rate increase? Sale discount and other discount we can give, which can be extended this study. Sale discount and other discount can given. Then the deterioration cost always less than by the holding cost. It increase the profit. So the concavity by the figure, it can see the phase 2 we are getting the maximum profit, and phase 3 same things. Similarly, same pattern I applied when the preservation technology not allowed. We comparing that dual price factor is existing there. Then we find price slightly reduced, approximately $0.5 per unit, and it's a huge amount convert. Then we find similar result, and their optimal solution, optimal price is this. Optimal time period is what? At that time period, 73 point. It play very significant role. If we observe that in the previous study, it was 74, now 73. So it means study saying that the replenishment period is reduced. At that time, we should place the order far better, means earlier. So if it is not there and we find that replenishment period is more than it, we can given the additional discount to the customer. Otherwise, it convert into the huge loss. Yes, case 3. when the brand preference not given. Now customer just depend on the preservative technology, but no brand means preference is given. So at that time we observe that the profit get reduced, means that approximately $0.8 additional profit getting on the basis of the brand only. So we can be aware about it, the brand plays significant role to earn additional per unit profit. Similarly, we find these things, concavity can be shown in all cases. Here replenishment time period, that is 73.99 in this case. Reason that initial inventory are more in this case. This is a particular cases I consider. There I fix the time, then case 1, case 2, and these all particular cases I discuss and compare, and I find that even we suffering from the losses also. Profit are not much better than, in this way we can proclaim that the optimum replenishment period and optimum selling price and optimal profit can be possible from the case 1 when the preservative technology allowed with a dual price concept. This is profit, shows by graphically, is a solution, case 1, phase 2, like that we can compare. Even sometime we getting loss also if we fixing. And what is period? That replenishment time period and dependent on the price, as I discussed earlier. That we can say this is profit and deterioration we can compare. As deterioration level is increased, profit decrease into the same manner, and it is what impact with initial inventory versus deterioration. It is suggested whenever the deterioration rate that is increasing, initial inventory also increasing. The reason that people not purchasing your items at that time, we should not reorder any medicines, any other things to the suppliers. At that time we should be stop it, because initial inventory are more, so holding cost will increase and deterioration cost suddenly increase. So we have to be control this deterioration losses. So in this study we find that 21% initial inventory and 10% impact on the profit can observe. So after that sensitivity analysis applied, where the sensitivity analysis apply, in future if something get change in any demand factor due to the internal or external factors, what's going on. So in this way inventory managers or industry well in advance they can take some decisions. For the decision analysis point of view, sensitivity analysis play very significant role, and where it is applied, in case where you getting the maximum profit, we can apply the sensitivity analysis only in this case. So sensitivity analysis, when change in 100% to minus 100 to 50% in their basic value of parameter, demand parameter or variables, this result is there, and there is the most sensitivity value we find. The sensitivity graph can observe, this is behaving pattern, we just observing, and what are the impact over the profit we can observe. It is clearly observed in the graph. Then what pharmaceutical and supply chain managers should do? As I tell you that replenishment period, they should focus on the replenishment period. If the replenishment period going to increase, so the deterioration level will increase, deterioration losses will increase. So what they do? They apply the discount near about to the expiry. Nowadays few online app they giving you 90%, 80% discount due to this reason only due to this reason, because their item get vanish after certain period, so they give you additional discount. We should not purchase it because their molecular value get already reduced. Retain customer through the shortage. During the shortage time period we can give additional discount to the customer, and that additional discount can lucrate to the customers to our distributor. Then invest in the preservative technology for the branded product. It is very important. But once again the questions arise, up to what level preservation technology can invest. So we can find the optimum point till at that point the preservation technology can be better. So it is, we find from it. Otherwise what happen? Once the time we means invest in the preservative technology, but the other side electricity cost will high. So it is also directly lost to the environment, then sustainability issue arise. So the optimum point of the preservative technology need to be observed, that can be identified from this study. Then produce to the customer preference. Factor K play very significant role. If the K factor plays significant role, demand will high, backlog order will always high. If K plays significant role, if the price is slightly high, customer will not affected from it, and we getting additional profit. Important, during the shortage time period, customer not move to the someone else. If I required medicine of the Mankind company, then I required the Mankind company only. I cannot replace it. Order counter cycling on the price dips, it is play very significant role when the raw item of any items, raw items, medicines or anything, raw item, we can purchase when the prices are low or when the season is off. That additional discount will be always better, and additional discount and holding cost we need to be observed. Generally what happen, purchasing department, they demanding more items, but the holding cost is also increased. So the inventory department say that not. At what point where the both are agree, that utility point, point of inflection or that particular point, we can purchase the items. So on basis on the price, we can take some decisions. The limitation of the study, it is depend on the particular assumptions. Trapezoidal demand preservative technology, if something get changed, like stochastic approach I applied, then result will different because it's a probabilistic model. If it is closed form of the optimal replenishment time period, like that online strategy is there and we have an online platform, then strategy should be changed. The preservative technology play very important role, we know that, but suppose that preservative technology sometime exist and sometime not exist. So I took that an assumption, but in future assumption can be changed. Like machine learning approach can apply, blockchain approach can apply. I write a research paper on a blockchain, on inventory modeling. So I find that when using the blockchain approach, the profit will increase automatically and the holding cost and other costs they get decline and diminish. So blockchain can also apply. In the future, different type of the techniques can be applied. Limitation, it is a deterministic model, not probabilistic model. If the probabilistic model, then the approach will different, assumption will different. So AI driven inventory management, blockchain process on the pharmaceutical chain can be extended, this is study. So question from your sides.
So thank you. It's a different topic from today. We of course talk about the other things. Now moving into the different area. Yeah, moving into the different area, scheduling and inventory problem. So any questions or any suggestions? Any inquiry?
That generally whenever we are taking the demand, most of the paper doing their work like the linear, quadratic or exponential demand. So you have taken the trapezoidal demand. So the pharmaceutical company, how they are getting the benefit by taking this trapezoidal demand?
Actual demand are the 8 types basically.
Okay.
One is linear, second linear decreasing demand, then ramp type demand, then trapezoidal, exponential demand functions there. Demand is linear, but further after certain period become exponential, king demand, and different type of the demands are there. But in a real life, it is observed that the molecular value of any item, especially for the pharmaceutical industry, medicine get force. And after certain period, when the molecular value are force, means that a medicine they prepare for the 3 years, but it's not working properly after 2 years. It has expiry value. We can use it, but we should not use it because their molecular value are lost. But
Sir, instead of trapezoidal, if you have taken the linear or exponential demand, so how it will vary?
that if I took the linear demand, it can work into the first phase only. I will
yes, you
discuss
have
then
taken
only
the
when the demand is increasing, growing. But what happen after the certain period, after
Constant
3
is,
months, then demand becomes stable, especially for the seasonal items like that dengue medicine or any other medicine which is required in particular time period only. So during the malaria time period, we required it. So I took the seasonal demand as an assumption in my assumption. So that's why the trapezoidal demand can play very significant role. So that's the reason I chose it.
and I think, sir, this paper we can extend it in the uncertain environment, that is demand if uncertain, like the Faucian
Like that,
demand,
in the fuzzy concept, if you want to apply that, for sustainability point of view, you have to another factor. For if you want to go to the sustainability point of view, then few factors need to be added. Like that, preservative technology is already existing there. For the sustainability point of view, another factor like that, carbon emission factor you can include. You can include water factor, water getting also wasted now. Recycling factor you can add. So these 3-4 factors you can apply additionally in this study, that this study can be extended for the
whatever
sustainability.
The cost value you have used, that also we can, the cost is always not fixed value. So we can take it uncertain also, and we can take it.
There's also the formula. Whatever the data I opted, that is also from the secondary data, which is already published in the several journals, literature. Few variables I took randomly. The cost factor we have to observe keenly. It would not mean that if the cost is high, that convert into the direct losses. And that also can be assimilated from this study. With the use of the preservative technology, we can understand that what is the cost there, minimum cost, maximum cost, and there is a floor. What is price floor, cost floor also there. If you want to observe particularly the cost, then concavity method that you need to be observed.
Sir, actually, depending upon the demand, cost will vary, sir. Suppose for one particular thing, high demand is there. So the company may increase the cost value. Like
No,
that.
particular item value cost will not be affected. Cost can be affected due to the deterioration or the holding cost. So the holding cost can be affected. I have another idea that all until now, I find that all researchers, they considering holding cost as constant. Even I consider, but in my next study, I am going to be explore that holding cost can be like a king demand. It can be behaved twice. Like here I consider the price, dual price. So the holding cost can be the dual price. What happened there? The cost will there, after a certain period, the cost will change. It would mean that in the phase 1, when the growing phase is there, the cost is different, but the cost will increase in the phase 2. So this type of the approach we can apply. And surely it can control your holding cost also.
Okay, sir. Thank you.
So,
Thank you.
Sir, you please little bit talk about the stochastic model.
Yes.
Please, little bit, for 2 minutes.
Stochastic approach, what happened there, like you are here, just take a simple example. The temperature of the Bhubaneswar is different and the temperature of this university is different. Even the temperature of this department and other department can be different due to the factor of what? Tree, water, AC and other factors. So we cannot proclaim that the temperature of the Bhubaneswar is same, is different. Same things happen here. Like that, I prefer for pharmaceutical point of view online. So I purchase always online. So the demand in morning, demand in evening, demand after 2 hours can be vary. Now what happen? I consider 0 to T. I consider this factor 0 to T and I replenish the order accordingly at T point. But when the point is T1, T2, T3, T4, T5, T6, so 0 to 2 time period, there is a several factors are there. And we have to finding the value of 0 to T1, T2, 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 T3, it's quite difficult. In this condition, we applying the stochastic approach. And there's another factor, epsilon factor, we added into the study. Epsilon factor always greater than 0. If the epsilon factor I added, so this time period I can avoid. And we can avoid any type of the ambiguity during the calculation of the profit and cost. So it can play the significant role, but this model is deterministic demand and further model stochastic become stochastic depend means probabilistic approach. So there the uniformity of the demand or everything gets changed. So we can solve it with a different method. several researchers, I find that in research paper, they mention simultaneously this demand, stochastic demand, but in their study, they consider assumption of only epsilon. So stochastic they're discussing, but they're solving basically deterministic demand. That is, sir.
So thank you for the explanation and
Thank you. Thank you, sir.
Thank you, Dr. Kosik, for your insightful presentation. May I now request Professor Pereira and Professor A.K. Mahapatra, Department of Mathematics ITER, to felicitate Dr. Kosik. Thank you so much, Professor Pereira, to chairing the session so far. May I now invite Professor Prasant Kumar Srivastav to chair the next two sessions of the day. He has been with us since yesterday.
Yes, thank you. You may start with the first talk.
Let me now introduce today's next invited speaker, Dr. Ravindra Jha. Dr. Jha is an assistant professor in Department of Electronics and Electrical Engineering at IIT Guwahati and is associated with interdisciplinary programs in health science, sustainability and design. His research focuses on flexible and sustainable sensors, breath biomarker detection and additive manufacturing for electronics. Prior to joining IIT Guwahati, he served as scientist at CSIR CIRI Pilani, where he worked on nanobiosensors and microsystem technologies. He obtained his PhD from IIT Kharagpur and subsequently carried out research at IISc Bengaluru. He is a recipient of prestigious fellowships, including the D.S. Kothari and SERB National Postdoctoral Fellowship. Dr. Jha has authored over 100 peer-reviewed publications and delivered more than 100 invited talks at national and international forums, including leading IEEE sensor conferences, etc. He is a senior member of IEEE and founding chair of IEEE Sensor Council Kolkata section and Guwahati subsection chapter. May I now request Professor Jha to continue.
So welcome all to this second session of the second day. There are two talks scheduled in this session. The first will be by Dr. Jha. So yes, so now the floor is yours. So just to mention, I will take only one question, okay, for each talk. And if there is any further discussion, you can have it with the speakers during the lunch break, okay.
Yeah, so I'm the odd man out. Okay, so it's a mathematics conference, and then you might see that electrical engineer is around you. Okay, but why I'm here, because your conference is something, you know, where you are considering computational mathematics for healthcare. Okay, and as ma'am has introduced, I work, you know, on development of different sensors for breath analyzing for non-invasive disease diagnosis. I will tell you what it all means. Okay. Further, you have seen, I mean, you have heard several talks where people has come up with various solution, but I have come here with one problem. Okay. And maybe that is an open-ended problem, and you know, I will seek some support from mathematics around me. Okay, so yeah, this is my beautiful institute. If you are around, you know, this part of country, please visit us. We have a very small lab. We call it Nanosensors and Devices Lab, hosted somewhere. This is not working, but yeah, somewhere that side. Okay, so what we primarily do is we use some two-dimensional material. We can discuss if you want what is this. Okay, during our lunch. Okay, I utilize these materials to develop sensors on different platform, including some, you know, silicon platform as well as flexible platform. Why I am talking about flexible? Because, you know, the current demand is having a conformal sensors on your body. For example, there are sweat sensors which we want to directly put on our skin to get some biomarkers and other things. Okay. Similarly, from nose, you know, we want some. That's what we are going to discuss today. That our exhale breathe has certain biomarkers. Even if you do not know biomarker, what I mean to say that these are some chemical species which we are targeting, you know, which we are detecting to get some insight of some metabolism that is happening in the body. All right. So we do all sort of, you know, fabrication and other things to get all these things. Okay. So this is what we are going to discuss today. Our exhale breathe contain, usually we understand that we inhale oxygen and we exhale carbon dioxide, but that is not true. Okay. We inhale oxygen, that is true, that usually our system is such that it will not allow any other thing to pass, but then we exhale around 4,000 different gases. Okay. Not only carbon dioxide. Okay. Now, when we have this 4,000 different gases, okay, there has been different clinical trials, different clinical reports which suggest that this particular gas, for example, is a biomarker for this particular disease. I will give you one example, okay, later on. Okay, I think that you will be more connected. Okay, say I'm sure that you might have seen this kind of devices at least on internet. Okay, people are trying to realize this. Okay, consider one particular gas which is very common, ammonia. Even we have studied this, we have came across these gases in class 5, 6, 7, whatever. Okay, ammonia, NH3. Okay, very small molecule. This is a very good biomarker for multiple diseases. Okay, so if you consider a healthy person, their breath contain around 150 ppb parts per billion, if you are not aware. Okay, 150 ppb to 500 ppb of ammonia. All right. Now, if the person is suffering if he or she is in certain disease condition, okay, like for example, I have pointed out 3 different diseases: gastric diseases, liver disorders, and renal problems. Okay, their ammonia concentration in the breath will increase, and this increment depends on what kind of disease we are talking about. Like if you see For gastric diseases, it is around 1.2 ppm, while for liver disorder, it goes to around 0.74 ppm or 0.75 ppm. And then for renal problems, it increases like anything, okay. So we have around 1.5 ppm. Even if you are not aware of these diseases, it's perfectly fine. Let me put it in more critical way. Diabetes is something very common. I mean, people are calling us nowadays a diabetic capital of the world, okay. Acetone, it's a kind of ketone, okay. Acetone, I mean, if you have not used acetone, or I'm sure you might have used for that nail polish removal and all, okay, that smell comes, that is a acetone actually, okay. Now, a healthy person also has a acetone in their breath, okay. He has or she has around 740 to 900 ppb of, or I can say less than 1 ppm of acetone in their breath. All right. Now, for unhealthy person, depending on what diabetic condition he is, okay, it can rise to around 1.8 ppm or so. Okay, that is huge. For a sensing person perspective, I can say that these numbers are huge. I can easily detect this kind of changes. All right. Now, coming back to acetone, usually we know that what happened actually when usually you know that what is a diabetic condition. So, a hormone, that is insulin, is something which is not released in the body on time, okay. And what happened that liver and other processes, they start thinking that, okay, I cannot use glucose, and it starts metabolizing the fat, okay, to generate energy. And in that process, okay, lot of ketones is emerged, okay. Some of the ketones come out of from the breath and some from urine, okay. But at both the point, okay, because I work on non-invasive disease diagnosis, for me both contains biomarkers. Today I am talking only about the breath, okay. So by this actually we our acetone concentration in the breath increases, okay. Even if you are considering this simple thing, let me put it in more you know, in much better way, that we are only talking about diabetes, but then there are multiple diseases, like for example skin cancer. There are biomarkers for skin cancer. A skin cancer patient has to sometimes give skin as a sample. You can consider that giving a skin as a sample is a big pain itself. Okay, we do not want to even spare even a drop of blood for glucose monitoring, and then thinking of getting our skin scratched just for a sample is a biggest you know problem for human being. Okay, so we look for some other alternatives. Okay, and this is non-invasive, as I have mentioned, that our breath has all these signatures. Of course, people are working in the domain. It may take another 50 years more, but this is the future people are working. Okay, so we are today only talking about the acetone. This is the simplest problem for the you know today's world. Okay, so this I think you are already aware that our breath. I mean, this is the system that I am talking about. We have hundreds and thousands, but as I am mentioning that there are hundreds and thousands of gases. Some of its origins are not known yet. Okay, so you can say that around 200-300 gases are only there, which has this potential of giving the you know idea of diseases. Okay, so not all gases have that kind of signatures. Okay. Major gases that are present are nitrogen, oxygen, water vapor, and all these gases that I have mentioned. Okay, so I have given you already a context that what we are talking about. Okay, so each gases, if I consider it as components, okay, they have their own concentrations. They all have their diffusion coefficients. They have their own adsorption behavior, okay, and they have their own reaction kinetics. Some may follow first order reaction kinetics, some may follow second order kinetics, some may follow some higher order kinetics, and so on. All right. So if I want to model this gas flow in you know from wherever it is originating to our exhale breathe, okay, I can, I have to be very cautious by considering, I have to consider all the components. Sometimes what happens that we work on sensor arrays, okay. So, sometimes what happens, it's not the only acetone that may be biomarker, okay. There will be say 2 or 3 or 4 different gases that collectively will give you a picture of particular gas, particular disease, okay. So accordingly the problem become more and more complex, but then solution become more and more easier. What I mean to say that, I am not talking about solution of this mathematical equation. It will be of course a complex problem and complex will have complex solutions, but if you are able to solve that, okay, the problem of human being will be easier, okay. You will have better solution, more accurate solution, and that will be more helpful for the doctors and other clinical clinicians, okay, clinical persons, okay. So breathe I can represent as a vector, okay, mathematically, and this is one of the way by which I can represent it. Now you have to be very conscious that till now whatever models has been proposed mostly consider it as a function of time, okay. I will give you more detail about this later on, but what I mean to say that the gas is not only the function of time. What is time actually here? I want to say that, or let me give a better picture over here. So this variables, I mean this C is my concentration, I is the some gas, okay. Now this I am showing it as a function of T and X. The variable T and X describe when and where the concentration of the particular gas species is measured, okay. This is also very important. Usually we are more worried about we have measured this concentration at what particular time, okay. But along with time, where I am measuring it is also important, okay. I will give you some example. Particularly I have taken a capnograph data to show you that how this X also matters, and what is actually X, that I will make you more clear in some time, okay. So T, I know that you understand it represents the time elapsed during the breathing process. Since exhalation is a transient process, the concentration of each gases changes continuously with time, okay. T is not something that you are not aware of, okay. What I want to show you that what is actually X, okay. X is something which I want to emphasize. I will just skip some of them, and maybe if required I will come back, okay. So because we do not have that much time, I will just okay. So let me explain this with one example, okay. So X is equal to, nothing is working actually. So X is equal to 0. This is the deep alveolar region where the gas exchange actually happen. So if we see your lungs, okay, lungs has small portions, small holes where actually gas exchange actually happen, okay. And there is the place where actually oxygen intake happens from bronchi, and then it flows, it allow it to pass through the diaphragm and go to the blood, okay. So it starts from there. So you have, so the position is, say for example, I mean these are just random numbers I have taken. X equal to 0 is this region, then it comes to the bronchi, and then this is your mouth is opening or it is coming from nose, and say again you have 0.1 meter or some say centimeter, your sensor chamber is there. You are measuring your data, your sensor, your sensor is placed over here. However, this region may also contain some very important informations, okay. You are measuring over here, but many informations are lost in this region, okay. So a mathematical model considering this C not only as a function of T, if we take it as a function of X, it will be really helpful, but then solving it of course will be more complicated. But if you get this kind of information, this will be a a very informative answer. Okay, like I have given one example since we are understanding it in terms of acetone. Okay, so say a concentration of acetone at 2 second or and say 0.35 meter means that the acetone concentration measured 2 second after exhalation begins at the sensor location 35 centimeter from the alveoli. Okay. This is just one example. I mean, similarly, you can consider for different gases, and your model will be more and more difficult. Okay. Now, once we have this acetone concentration or any other gas concentration, I'm sorry, this is T, okay, is obtained, which is actually the state variable that describe the acetone concentration everywhere at every instant, multiple analysis can be done. Okay. These analysis include the you can make prediction models for acetone transport, you can predict the sensor response, okay. You can extract the clinically relevant features from these curves, you can build even a disease model using this, okay. Along with that, you can estimate the blood glucose and maybe ketosis condition and so, okay. Like I have given one example, okay. Acetone is transported by airflow and diffusion, not only by airflow, it is also diffusion that I will talk about, which can be described by, here I have taken only a one-dimensional convection diffusion reaction equation, and this is the equation here. Let's have a look on what each and every component means over here, and I think that that will clear everything, and then we may conclude. Okay, the first term here in this equation, okay, this particular term del C by del T, okay, this please note that I am not using T and X over here, but it still contains that T and X. I am just avoiding that. Okay. Now this shows that how acetone concentration changes with time at a fixed location. Okay. Now beginning of exhalation means that concentration will increase, then there will be end of breath. I have shown you one cycle, if you remember the capnograph, this cycle, okay. Initially it will rise and then it will die. I mean, it has different phase, phase 1, phase 2, phase 3 and phase 4. Phase 4 is nothing but it is coming back to the baseline only, or respiratory baseline or inhalation only, okay. And during the steady state exhalation, it will be of course 0 because I am considering it as a time function, okay. Now the second term, which is even more complex, is actually represent acetone is carried by the moving breath, okay. Here I am also considering exhalation velocity. Sometime our exhalation is very slow, sometime our exhalation is very high, and so on, okay. So we have to also consider the second factor, all right. Then the third term, which is the diffusion term, okay, if acetone concentration is high near the alveoli and the lower, and of course it will be lower towards the sensor. Initially I am not, for example, if you are not sitting in a acetone chamber, of course the concentration of acetone at the sensor will be very, very less, or it will be 0 basically, okay. So what is happening is you are pushing the gas from one point to another point, but at the same time along with the velocity there will be some diffusion of diffusion of acetone. You know that if there is a concentration gradient there will be diffusion, okay. So that is also happening in parallel, okay. I mean, depending on the condition you can make it 0 also. If the diffusion coefficient, you can consider it as 0, but usually it is non-zero quantity, maybe 10 power minus 3 or so, but it will be a non-zero quantity, okay. The second derivative actually measures the curvature of the concentration profile, and depending on peak conditions you can have a different I mean you can define it in different ways, okay. So dA is the diffusion coefficient, and a larger diffusion coefficient implies a faster molecular spreading, and a smaller diffusion coefficient implies a slower spreading. And there are other interpretation from diffusion coefficient, and this diffusion coefficient is the same that we have seen over the time, okay. One term that I have not discussed here is the RA, okay. we have to consider this array because this accounts for any other process that changes acetone concentration beside this kind of transport. Okay. Now this process could be because of multiple reasons. It can be because of it can be additive as well as the subtractive in nature, like acetone released from the alveoli will be addition, while the adsorption onto the tubing on the surfaces, okay, is actually negative. I mean, it is decreasing the concentration. So acetone was carried from the point it has been released to the sensor point, and on the way it is getting adsorbed at the different surfaces. So it is basically decreasing the concentration. Similarly, there are other ways. Yeah. So now once you have this C obtained, okay, which is actually the state variable, as I have mentioned earlier, I have given you one example of predictive acetone transport. Similarly, you can predict sensor response, extract clinical relevant features, and so on. Okay, the predictive sensor response depends on adsorption of acetone on the sensor. For example, these are some of the devices that we develop in our lab. You can see that this platinum has been patterned. This is kind of 5 micron. In between there is a gap of 5 micron, and the thickness is we have titanium beneath it, and on top I have gold. Okay, so this is a kind of very simple structure that we fabricate, and the adsorption of acetone on this surface, you know, will help me to establish a model for sensor response. What happened that in laboratory we have generally generate this acetone by certain means, and sometime that generation in which our breathe air is or breathe acetone is there is not available. Okay, so sometime we have to model it in such a way that interpolation and other things can be done. Okay, there are multiple ways these sensors can be fabricated. I will not go in detail. Okay, these are some of our efforts that we have brought the old generation sensors on a single semiconductor chip. Okay. I mean, depending on adsorption models, you can come up with the different equation. I have used this concentration that we have obtained from our previous discussion. Okay, here for a simple adsorption model, here theta is the fraction of occupied sensing site. So what I mean to say that this is, for example, a sensor, and say analyte, say acetone is interacting with this sensor at every point. Okay, so theta means the fraction of this available adsorption site which is already occupied by the acetone. So that will not be available for next batch of acetone. It is already interacting or it is already occupied. All right, so let me skip some of them. Okay, so yeah, so to conclude, you can do a lot of feature extraction, dimensionality reduction, and machine learning, which can transform complex breath data into clinical meaningful biomarkers, enabling accurate disease detection and monitoring. I have just shown you one example. Okay, I mean very simple example, not considering anything complex. Okay. Further, integrating physics-based models with artificial intelligence offers a powerful pathway towards non-invasive real-time and personalized healthcare diagnostics, and this can bridge actually mathematics, sensing technology, and clinical decision making. Okay, the area is totally interdisciplinary. Okay, I mean I have talked just one perspective, and this is the area where a lot of things are needed. Okay, I have included this. In case you want to understand more on these sensors, how they work and on, multiple NPTEL courses are being run. Okay, they are available free of cost. You can have a look on these if they interest you. Okay. And I am thankful to all my students. There are multiple PhD students who are solving these problems, multiple postdocs are working. Okay, and then thanks to my funding agencies, and thank you. Thanks to the organizers. Yeah.
Thank you so much for being on dot. My apologies for making
Perfectly
you
fine.
rush.
I finished on time, right?
Yes, perfectly on dot. I can allow you still one question if there is any. Otherwise, you can have a discussion during the lunch break. Yes, yes.
One query, sir. Actually, as you told that the PD, which is the adversarial diffusion equation. So, what do you do with it? Are you put this equation in some package and then solve it, or what do you look?
How to solve this?
No, no, what do you do actually?
What did you, the equation which you showed,
Yes.
whether you solved it?
No, no, I have not solved.
So
I
what
have
do you
given
do?
you a problem that please solve it and give me this. This I am given a one-dimensional
Okay,
model. It can be
okay.
even more complex model. Okay, I have considered its flow in only one direction, but it is not flowing like that. It's a complex molecular dynamics problem.
Okay, okay, thank you.
Thank you so much. Thank you. Your pen drive, please.
Thank you, Dr. Jha, for your
Thank you, ma'am.
excellent presentation. Now I may request Professor Srivastav sir and Professor Milu Acharya ma'am to felicitate Dr. Jha.
Okay,
Madam, please come this side.
thank you so much. आइए सर एक फोटो खींच रहे हैं हम.
She's giving you memento.
I'd like to invite Professor Mitali Madhusmita Nayak as well.
Thank you.
And the region C can explain better.
कोई reason नहीं है, come here. Sir, please. Ma'am, Asil. He is my former student. Oh. Thought last 18 years I know.
Thank you, ma'am. Thank you, sir. I now introduce
Thank you,
the last invited speaker of the day,
अरे हाँ बहुत अच्छा रहेगा.
Professor Subhash Chandra Martha. Professor S.C. Martha is a professor of mathematics at IIT Ropar. He earned his PhD from IIT Guwahati in 2007 and was an NBHM postdoctoral fellow at the IISc Bengaluru. His research focuses on applied mathematics, particularly mathematical modeling of the water wave scattering, hydrodynamic loading, fluid flow through the porous media, and numerical solutions of the Fredholm integral equations. He has published 88 research papers, guided 10 PhD scholars, 4 ongoing now, and delivered our 60 invited talks. A member of National Academy of Sciences, NASI India, Professor Martha has received research funding from the Department of Science and Technology, DST, Government of India, and has led several important leadership roles at IIT Ropar, including HOD Mathematics and Associate Dean Students Affairs. His academic collaborations and visits include in renowned institutions such as ETH Zurich, the University of Zurich, Shanghai Jiao Tong University, and the University of Melbourne. I may now request sir to join on the stage and continue the presentation. Thank you, sir.
थोड़ा सा आगे आ जाएंगे. From the back side, can you have little bit closer towards this? Those who are back, can you shift towards this line so that we will have. Fine, fine. Fine, I think mic is not required, but if you put, then it is more efficient to listen. Okay, fine. So, good afternoon all of you, and in fact, Jai Jagannath to all of you, because already we have good deities here, and we should pray, because this is temple city. Bhubaneswar is also called temple city, but I always call Odisha is temple city. In fact, I was thinking that many will go and move, but nobody is there, but at least few are here to listen the talk. So, thank you that at least you are here. and it is my honor that to thank the organizing committee, special thanks to Mitali and Lopa who connected me, and I thought I should come because last 2 years back they had a conference, I think 2024, and by Professor Apul, but I couldn't come due to last moment there was some urgency was there, so I couldn't come, and then I thought that I should visit this time. And in fact, when I was entering at 11 o'clock, I was looking that Professor G.C. Das is attending all lectures and listening all talks. I think all should follow that, how a old professor still sitting and listening all talks. So that patience we all should create. In fact, I do not have, but all we should create. And nice to meet many people who are already spoken, already Professor Srivastav, my friend, and my senior, my bhai is from IT, Chand bhai is already spoken this morning, and nice to meet Professor Pera, he is here who hold RAM 2025 at Colombo University. So though I couldn't tell hello, so nice to see you. So let me quickly tell few things. I want to show this picture, Professor by B.P. Acharya, though he is not here or he is no more. And I met him when I was in a conference at KIT University, Bhubaneswar, and where sir was also giving talk. And in fact, sir gave the talk, after that I gave the talk. He was here, then we took lunch, and then he told Subhas, you are a young fellow and you did from Sambalpur University and then Guwahati and came here, so you should come sometimes to ITR. But I couldn't come and I couldn't meet sir. But I got opportunity this time. I thought, let me tell about sir. And in fact, when sir gave the lecture at KIT University, I can tell you that I always know that Acharya sir and others sir from Utkal University, they do more on analysis. And sir gave integral equation with a analysis approach. And when I analyzed all the publication behind this, sir was publishing applied mathematics and computation, which is recent. If you see these days, applied mathematics computation is Q1 with a impact factor 4.5 or 5. And with this, sir has published, I think those who are young people at ITR or some other place at Bhubaneswar, fantastic research with analysis, motivation to solve integral equation in different style. And I was surprised to see that. And though I was thinking, but my interest, though little bit integral equation, but not much, but that's what little bit I can tell you. So he is really a nice teacher and a good guide and good mentor. I think he has, after his retirement, he spent a couple of years at ITR. I think many people did very good, wonderful work with him. That's what to tell about sir. And as I already told the young girl about my area, basically I look more on wave structure interaction modeling and very less on integral equation, and particularly the integral equation when come to the picture in wave structure interaction, either it is a Freedom integral equation of first kind or second kind, my interest is always to solve numerically. Okay, so, but I will not show much on integral equation, I will show on applied mathematics, because the conference highlights our computational mathematics, and though not healthcare, but at least I thought the engineers, if they are interested, from those who are from civil engineers or mechanical engineers, can also utilize this idea. Okay, so as a mathematics, I will highlight more mathematics, less physics or the fluid mechanics. Already my friends, some friends told about stability, I think on population dynamics, but this wave dynamics more on will focus on mathematics. So as I wrote that in abstract, if you have seen the abstract book, I wrote that mixed boundary value problems occurs naturally when you model any problem of engineering, or in particular as we will see that wave mechanics or water wave mechanics. So while understanding such boundary value problem are immense pleasure to the engineers, but for a scientist like me is to solve the boundary hull problem analytically more on semi-analytically. Up to certain extent you apply the analytical method, then follow the numerics. That is what we will see in couple of problems here. As already my friend Srivastav told that, Prashant already told that I should finish by 1:30, but I will try to, but you can just remind me for 5 minutes so that I will check out. Okay. So, as I told that wave dynamics, so is a particular of water mechanics where the waterways in particularly in coastal engineering or ocean engineering is a vast area where we look the application of these surface water waves. So, the surface water, there are many waves you will see in ocean, but particularly this kind of waves is not our interest. Model this kind of needs more experience, more energy, everything, but admitting these regular waves where the amplitude is, you see that the amplitudes are equal, this model is surface, this is called surface waves, is more interest to all of me, including many like Lopa and other guy who met today. What is, I forgot your name again, Sanjeev. So, they are also in the similar line of understanding boundary hull problem in water waves. So, you may ask me that why, where is the surface waves usually, because in ocean usually there are big tides etc. Again yes, tide also you can analyze through the surface waves also, because solving surface, you will see that the solving surface waves equation is not that easy. And so, if you look whether it is a ocean or sea where or the lake, when the fisherman goes or the launch he goes with the launch, then you will see that due to interaction the waves are created and these waves are having the amplitude, constant amplitude. So, that kind of are called the surface waves. Of course, high pressure of the wind also surface waves are created. Now, where you apply? The applications are many. In fact, I was talking in the car today to Mr. Sanjeev. He told that he is from Digha or what is Sundarban. So, I don't have the picture of Sundarban. Sundarban has a good breakwater which is mangrove. I forgot to tell him. It is a mangrove in the Sundarban, in the coastal belt. You will see that there are many mangroves they have put, the government has put, just to make the wave, the amplitude of the waves to the smaller, so that the force exerted by the wave will be small, so that the effect to the coastal will be less and there will be less damage. So, the breakwater has varied application. In fact, if you have gone to TFR Mumbai, the sea is the little bit just maybe 1 kilometer, 2 kilometer away from TFR, big stones are there. These stones are called the solid breakwaters because that only stops the wave there, otherwise there will be heavy damage. That is what you can see that these in the real state, these are the application of these waves with a breakwater. And you can see that in fact many places including Japan, Taiwan, they have now floating vessels, and because they have less space. So, they are using now ocean space as the floating models, and these floating models are also application of wave structure interaction. As you can see that they have a breakwater here, so that it can break the waves, they can break the amplitude of the waves to the smaller amplitude by this. So, these are the few application, but you may ask that where exactly all the things, but I am not interested to that, but my interest is to solve what is the boundary hull problem associated with this, so that I can look. Okay. So, when you look this surface waves with breakwater, so the breakwater what mathematical how to model it. So, it can be thin barrier or thick barrier, it can be array of barriers, or the barriers can be at the surface of the water, or it can be bottom of the ocean, and then the bottom may be also can be some undulating bed, it may be oscillator in kind, it can have trench type, it can have step type. Of course, there are huge literatures on this. Okay, so what is the scattering then? If the wave comes and in the ocean and strike this structure, whether it is upstress structure or seashore structure, then reflected back and transmitted over. So, aim is how to see this prediction of this transmitted wave and the reflected wave. Of course, the force by this barrier. So, mostly in the water mechanics the people usually study different kind of this, but more interesting part is on the undulating bed. One kind is the sediment transportation and sediment transport as well as the resonance. This kind of work was in fact I did not highlight the C.C. May, who is recently passed away. He is from MIT. He introduced the sediment transport with the Bragg resonance there, but I will highlight one case of resonance in which we did recently. And as I told that, of course, you will have rigid and porous barrier. It may be thin or thick, ocean may be flat type or undulation is there, but I will try to solve only linear problem. Of course, I have solved only one or two non-linear problem, but mostly linear problem, because as you see that linear problems are somewhat more difficult also to solve. Okay, so let us see that. So as you have seen that, suppose you have water in the ocean and you have a surface wave, and then suppose you have the bed is having the structure of like this, and then wave comes and propagate over this, so that it is reflected over and transmitted over this topography. Now you may see that what are the concerned equations. Of course, many fluid mechanics people who are associated with this, so they will know that one is the equation of continuity, is the conservation of mass, and if incompressible fluid, then it will be del dot U 0, so U is the velocity of the fluid, and then if you take it is potential kind or irrotational flow, of course you may tell that there is no irrotational, again to get the assumptions again simpler, and then I took irrotational flow or potential kind, hence we will have Laplace equation. So my governing equation is the Laplace equation, and then we will apply the conservation of momentum on the surface, that is the equation of motion, and which is this Bernoulli's equation of this, and you can utilize this. So and then of course you will have kinematic conditions, because if you take the surface elevation is eta, then you will have a kinematic condition where phi is the velocity potential. And already I told that in case you put tension on the surface, then your equation will be of this one, you can see Coel-Kunduk book, and then bottom conditions will be this nature. If it is there is undulation, which is represented by the curve z of minus hxy. And suppose you take the linearized, assuming that the elevation is small and the velocity is small, so that the square term are neglected, all square term neglected, product term neglected, then simple you can have this equation. Assume that your bottom is flat. So there is no this one, let it be flat, so z is equal to minus h. So I have flat bed and the linearized condition, very easy to solve. How to solve it? You can solve by variable separable method, Laplace equation with mixed boundary condition, you solve it by variable separable and you can get the solution this. One can verify easily that it satisfies the Laplace equation with the surface condition as well as bottom condition. So this is a wave, you can already this can see that. And very nice that it has to satisfy, this transcendental equation must be satisfied, this is called dispersion relation. And analyzing the roots also is not that easy, who are beginners it will take time, those who are already acquainted it will take less time, because you have to plot the graphs and see that this will have two real roots and in fact many imaginary roots. So analyze, but if you want to solve by Newton-Raphson method, you will get one root, but for computational purpose you want to draw this, then you have to if you want to take all these imaginary roots, then you have to choose proper initial guess. So the Newton-Raphson method give one root, so you have to take many initial guess, so that all roots you can get. So at least you will have finite number of roots to predict that. Okay, let me tell you quickly at least one or two problems. So as you told that bottom is having undulation, but again I took bottom is flat, I will show undulation problem differently. Assuming that there is a this is the surface and there is a wave and y equal to eta, and then I put a thin barrier on this, and let me that is at this position at 0 and then length is a. So, wave comes and strike, reflected back, transmitted over. I will have same Laplace equation. I just eliminate the t part because I found that it is time harmonic. So, if it is time harmonic, I can extract always e power I sigma t, because the sine and cosine are real part of e sigma or I sigma t. So, I can write down in complex valued form and write down that real part of this complex valued function. So, that phi will be complex potential. So, just t I have removed just for simplicity, you can bring back at the end t to there. So, you will have Laplace equation again, this is the combined condition, the Bernoulli equation and kinematic condition, because I have just eliminated the t, and so that eta is eliminated, but you can get back the solution phi and put in eta, so you can get elevation. So, bottom is flat, so I equal to h, and what is there? So, this is a gap. So, if you take that pressure is continuous, velocity is continuous in this gap, you can have two more additional conditions, and on the barrier, of course, the horizontal component of the velocity is 0, right. So, you can have this, and what is the far field condition at far away. So, this side you will have incident wave and reflected wave at x equal to x less than 0. So, this side is phi incidence means incident wave, and this is reflected wave. So, r is the coefficient because I took minus x because it is traveling again negative x direction after striking, and this is the incident wave followed with accompanied with t is the transmission wave. So, this is reflected wave, this is the transmitted wave. So, if I determine this r and t with along with phi, then my job is done. So, as we know that when there is no barrier, already we solved variable separable. So, let us take that same solution, right. So, you will see that I took all solution because I told that many roots of the transcendental equation there, and that roots, all roots are nothing but the eigenvalues of the problem. So, because when you take variable separable method, the Laplace equation with mixed boundary condition will give rise to one of the problem will be a Sturm-Liouville problem, and the solutions are eigenfunctions, as we know that in our MSc background. So, I wrote all combination eigenfunctions here, and then I wrote this is the Ivan-Scan modes, which is the corresponding to imaginary roots, and this is the transmitted wave corresponding to the propagating mode k naught, or because k answer the roots. So, this is for towards x tending to right hand side x tend to infinity, and this is x tending to minus infinity, the reflected wave, incident wave, and then the corresponding to Ivan-Scan mode, which are corresponding to the imaginary roots. And if you can tell me that we wrote the series solution, of course, which is possible satisfying Laplace equation, free surface condition, bottom condition, and some far field condition. Now, if it is a solution, it has to satisfy the rest equations. So, what are the rest conditions? It has the condition on the barrier and condition on the gap. So, that's what I just applied. Gap means the length is L of the barrier is L and gap is L bar. So, I just wrote it the equations in these two they are substituted. So, what I took very simplicity for the simplicity, just you take the discretization point on the L, take the discretization point on the gap, you will get many equations. So, the idea was generate too many equations x equal to b from these two equations, one is equation from the barrier, another equation on the gap. Just determine from this how, if you treat that many points, then you will have infinite many equations, but the unknowns will be finite because the series is convergent. So, if you took this, so you will have a system of equations which is overdetermined system of equations. You can apply by least square method. You may tell that sir ODS may not have a solution. This is a physical problem, assuming that physical problem has solution. So, this ODS has also unique solution. So, you can apply the least square method and then take that this one, and of course, those who are using MATLAB, just command is A star A slash A star B, which operates Gauss elimination method. Of course, you can take also inverse QR decomposition method and can do that also. Now, you may tell that sometimes this choice of this A star A may be singular, or A may be A star A will be singular, or determinant will be 0, how to find out inverse. So, to take the discretization points in such a way that and the parameter values that, so that A star A matrix the determinant is non-singular. And of course, you can look if you want to approximation, as somebody means that what is the error, you can tell that equivalent error which is given by this. Okay, so this is again some literature, already it was done by analytical least square, but aim was with my student to see a straightforward method by algebraic least square, that is what we did. And in fact, Professor Mandal and Dolai, they did with the Galerkin appreciation method the same problem, and then they got upper and lower bound, but our aim was straightforward method to have algebraic least square method and see that how the our absolute value of reflection coefficient and transfer coefficient or reflex coefficient is nearly equal to there. So it was quite straightforward, and I will not spend. Of course, the referee told that why to equal discretized points, can you take unequal discretized points? The idea is to take the zeros of Chebyshev polynomial first kind as well as second kind, and we showed the same thing. So let us go ahead to this work was very simple. That's what we communicate to Sadhana, and they took it quickly. So those who are interested can go later. So little bit quickly, the next problem, if you put along with barrier some undulation, will the same method is possible? The answer is again no. So what we did to solve it, we started with the same problem, but additional condition is as undulation is there, I took del phi del n equal to 0, where n is the outer normal to this undulation. So I took it in a different style, like take the perturbation expansion, then take the 0th order and first order and solve at least up to first order. If you do that is fine, but one can go with his spectral analysis with different order. I will maybe I will not show that thing here, but it is some literature it has done by in other way. Okay, so this is by Green function technique, and the 0th order problem was solved by the idea just now we did least square method, and the first order problem was by Green function technique. And this was just we took the sinusoidal ripples, the bottom was sinusoidal ripples, and we matched with the without undulation the first case actually. Okay, so let me show you one idea that this gentleman was telling. So let us have instead of thin barrier, thick barrier, and then don't take small undulation, because if you take small undulation, perturbation expansion you may take. So don't take small undulation, but you take this one. So what we do, we do it by divided 3 regions, eigenfunction expansion here, and then you can do by this boundary element method analysis on this, and then eigenfunction expansion. So this is coupled eigenfunction expansion. I will take just 5 minutes more then. Just I will highlight one more problem, then I will go to my last one. Okay. So these are all some trends problem, but I will show that some resonance problem that what I want to tell. So the idea about this undulation which is showed in the beginning was by Ray and Sisime actually, who recently just last 1 week before he expired. Long back he gave this resonant reflection of this surface graduates, and in 2024 this Penzin Lin and his group, he is the main editor of Applied Ocean Research. So they did the class 2 Bragg. So this was class 1 Bragg resonance, and this was class 2 Bragg. So if you go to class 2 Bragg resonance, then it takes a little bit in a different style actually. Of course, now recently they have done in JFM in class 3 Bragg resonance. So we are thinking, but they already captured it. So what we did, we took it current in the surface, and tension we took it. So we have little bit modified equation on the surface, and then we look all possible in the bottom having 2 components, 2 wave number, and surface is one commoner, one wave number, and then all interactions with the bottom and the surface, all possible interaction we took. Of course, there will be many interaction, but we classified only this class 2 resonance of this kind. So we took it and solved by multiscale. So this was very wonderful actually, the multiscale analysis, which is you have to introduce 2 more variable again. Of course, they are also function of x and t, and then use this analysis, but this series expansion is valid throughout. But perturbation has a limitation, but multiscale has, you will get all possible the problems it will be resolved. There is no problem there. So these are a few actual observation with respect to current, and in fact the referee asked that how many number of ripples are required to have full reflection. So with a different current we are analyzing the peak reflection actually, and so person how much time will take? 5 minutes or 2-3 minutes? Just I will show some interesting slide. So this is the publication as Prashant is. So one more work we did with a continual self, again with singularity we took in integral equation approach. This was with Professor Mandal. It was also in Journal of Engineering Mathematics. So, this is all about work. There are many works we also contribute on different topography as well as elastic plate, etc. So, let me go to conclusion. So, we have solved different boundary health problem by different techniques. Some 2-3 slides, interesting slide I want to highlight. So, I always, wherever I go, I want to tell that you must have plantation, tree plantation, you must have one man, one tree, because these days we require, right? We require actually for good health. And even if you have like drumstick tree, whatever plant you like, you plant it, and if it is useful for you or giving only oxygen, whatever you like, you must have. That is what we have many drives. The next one is, if you want to have good research, you should have good health, and if you want to be active and healthy and happy, you must have exercise, yoga and pranayama. I am telling that you may not have time in a city. If you live, you do not get place also to have this, but in your room itself you can do all the three. So, if you are not doing, do at least for 5 minutes. Okay. Today if you do 5 minutes, tomorrow you will do 10 minutes, you will see that the effect of that. This actually came across during International Day of Yoga, that this fellow, I am not, he is not my relative, nothing, just he is a very good fellow, Saurabh Bothra, and he was very nicely talk he gave. I was attending, he was freely giving, so I attended it and I was motivated from him. He is in fact a IITian, I came to know after going through. And the, maybe another one is, if you want again have good research mind, it will have good health, but good health will come if you avoid the junk food. So, if you are taking more junk food, so avoid that, occasionally it is fine. So, that will give good health, good habit and active all. And I was more inspired by Professor Swadhananda Patnaik. So, I do not know whether I will meet him this time or not, but he always inspire many students. So, I was one of the students who inspired and joined IIT Madras, and that time Chandbhai was not there. I was PhD student or project student for 2 years. I left that to Guwahati and completed my PhD there. So, thanks to sir that and that is what you have invited me, I am here. And just 2 days before I talked to Professor Mandal, and in fact he is my PDF mentorship at ISC. Always I am telling the research scholars, as sir was telling that sir, student want Q1 quartile journal publication. I told sir told that what is Q1 quartile, then I have to explain what is Q1, Q2, Q3. I told that do not worry, you should be worried about mathematics. So, you need quartile, you need impact factor, you need publication. Then I told them, sir, what we should convince to the student, the research scholars. Then he was telling that he told that Professor Chakravarti also told him, he is a good friend of Professor Chakravarti. Then he was telling one should study, and three times he told work hard, work hard, work hard. So, you must work hard. If still you want to learn anything, you must work hard as much as possible. So, with 30 minutes I cannot give you many things, just I gave you idea that how computational or applied mathematics is still will give, you have to understand many things, including integral equation, including fluid mechanics, Newtonian method, many numerical methods, etc. And then you can get then at the end maybe 1 or 2 Q1 papers to get your PhD. That is all I think. Thanks Prashant for this, and these are my groups. I now recently up to this, these 4 people are there now recently. That is all, and these are my collaborators. That is all. If you have not visited IIT Ropar, I invite you all. Sometimes if you get opportunity, visit IIT Ropar that side. I will happy to host you. Thank you very much.
Thank you so much, Professor Martha, for wonderful talk. One question I can allow that can be very brief and straightforward if there is. Wonderful. Thank you for no.
Yeah.
So very brief, please.
So thank you, Professor Martha. Actually, so I am very much impressed about the first slide. So you are telling about the Professor V.P. Acharya. So till last breath he was associated with our department.
Okay.
as well as our university. He was the good mentor for the university, and he is very strong in analysis, and very, very strong.
Yes, I know that. Yeah.
So, and secondly, I am also the Swadhin Patnaik, though I am not directly in contact with him, but I know he is also the very strong in analysis part. But so at this stage, and for his first dialogue met at Delhi, that you are the young man, you come to the ITR, and I hope, so keeping his request on that day, so you are coming here. I am so, on behalf of our department, I congratulate you. And so one more information, whether you know it or not. So his daughter, Professor Milu Acharya,
I
so
know
he is
that.
the most senior, most professor in our department. He is working there, and he is also, her contribution is also a lot.
Actually, I couldn't get the search photo in Google. I wrote ma'am, and then I go to the website, saw her email ID, wrote it just day before yesterday, and then I said, so yesterday I just put it. I thought if I am going, I should highlight, and that's what my aim was. All youngsters, including me, should be motivated how this senior professor, including this Siddhas, they worked, and that's what you can see that his student who has also published, Professor Mishra has published around 300 plus papers. So one should learn, right? Still the dedication should be there, and that dedication we all should continue. That's what my aim is, that to show few our sirs who really did very wonderful, and we all should motivated to do the same. Yes, sir.
Okay. Thank you, Professor.
So thank you so much, everyone. There is some, please,
Thank you,
Yeah, thanks
Professor
again,
Martha.
Mithali, that we met long back, and after a back in here. And I am happy that many seniors, my friends, are ITR, so I loved to meet them. And thanks to Professor Satyanarayan Mishra, that always he remembers. So at the end, we met each other here. Thank you.
Requesting Professor Srivastav sir and Professor Santi Lata Champati ma'am from Department of Mathematics ITER to felicitate Professor Martha.
Everyone should join. This is Harry Potter. Maybe one more. And then we can move for the lunch.
Yeah.
just one minute.
Thank you all. All can join for the photo session.
All can come. Can have group photo. We are absent yesterday, so.
ପିଲାମାନେ ଯାଇଛନ୍ତି
intersection point.
Thank you so much. Thank you, everyone. The session chairs, the speakers, the resource persons. So this comes to the end of our offline keynote talks. And in the second half, we have the technical sessions online. followed by the cultural and the dinner with the certificate distribution. So I request everyone to be here around 4:35 p.m. so that we can continue with the same. And for the technical sessions, we will have it in 5:51, 5:52, and 5:53. Today we have only 3 online sessions. That's it. Thank you, everyone. We can go for the lunch. Hungry stomachs.